All right. Hello, everyone, and welcome to my stream today. Yeah, we're talking about transitions again. Come say hi in the chat once you're here. But I wanted to get down today into the real, like, what are we actually technically solving here? Like, how does it work? I want to get a little bit deeper. We do a lot of Scheduler, I imagine. But yeah, this should be fun. Let me just get some stuff open and set up here. But this is kind of the next logical place where I'd end up. If you watched any of my last stream where I talked about async signals, I've been kind of hovering around this whole transition topic and implicit versus explicit transitions. And even if you go back to the very first demos done around React 16, they were looking at this feature from two different angles. And I want to look at those, and I want to look specifically at the demos and examples that have been put out and talk about what's good and what's not good. And like, as I said, approach these from like a general engineering standpoint. Like, forget transitions exist. How would you approach this? All right. Yeah. Hey, how's everyone? Yeah. And this is also going to be my last stream of this year. So I know some people probably have already gone on break, but I think there's going to be some interesting content here. Yeah. Let's see here. I'm going to get Twitch chat open too. Yeah, okay, there we go. Good. Yeah. Okay. Yeah, start. Hey. Yeah, I actually think I started on time today, which is the first time in a while. But just give people a couple more minutes to kind of start on. But where I've spent a lot of my time talking about transitions, I've been talking about one side of the two pieces. I've been talking about what the React team called the IO side. I've been talking about parallelizing, you know, like the tab demo when you go back and forth. And I put this today. I want to look at the CPU side a little bit because we never really focus on that. And I think yes, the CPU side is less important, but you got to kind of understand what the problem is solving. And it's these topics often get kind of wrapped up together. Like, you can have what I consider transitions without time slicing. Like, you can put them separate. For me, transitions is like more of a general envelope talking about this a way of entangling almost transactionally async work. And for me, time slicing is specifically the preemptive scheduling around this. And you don't need to have interruptive or preemptive scheduling to be concurrent, right? You can just like you need scheduling to a degree, but you can be like, okay, I'm going to run this here and then run this here. You don't need to be like, okay, something new came in, I need to interrupt it. You know, like, you can just lay the stuff out, you know, like finish the current stuff you're working on, schedule some, you know, transition quote work, and then, you know, run it at the appropriate times without necessarily ever interrupting anything. So why time slicing? And what is time slicing? Like, how does it actually work? So as I said, I think we're going to look at those demos today, and we're going to look at what makes them good or what makes them not good. But I think first, we probably should get started here. Is we should get into talking about a little bit about the JavaScript event loop. Thank you. Yeah, I am having, I'm looking forward. I go on holidays as of, today's my last day, and then I'm taking Christmas, so look forward to that. Yes, thank you. And yeah, I'm gonna put this right at the beginning. If you like the content of this video, I know that's too early already, but please like and subscribe. By the end of the stream, if I say this, no, not as many people are going to see it. So it does help the channel a lot. Getting more views if people actually, go and like and subscribe. If you're here right now, you're going to watch this. So you might as well just, go in and hit that like button. It definitely helps, Okay, so definitely let this kind of meander a little bit, and let's get started here. I'm gonna pull up an Excalibur and I'm gonna share my screen, and we can talk a little bit about the JavaScript event loop. Actually need to find a nice spot in my, I've got like this giant canvas that I've been that I've been working on here to throw stuff in. Let's find a space that hasn't been occupied. Okay. Somewhere over here. Okay, so let's talk a bit about the JavaScript event loop here. JavaScript. I'm sure most of you are familiar with this, but I think it's important for us to like start on this topic here because it's kind of foundational. There's some great articles out there. Lydia Hall, formerly Vercel, Bun, whatever, did a great article explaining how the event loop works. Or I read that probably. But like I've even watched content from say like Theo or something where he's talking about it and trying to explain it, and he doesn't still quite get it right. And the reason the JavaScript event loop is really quite powerful, but it is all the details make it a little bit complicated. As how they enact altogether, but they're kind of like this very powerful primitive. So like anyone who's working on JavaScript frameworks is very, very familiar with the event loop because it really dictates how we can approach problems. Okay, so the first thing is JavaScript event loop has actually evolved over time. Just gonna put that out there because originally you could kind of view it like a queue, right? So we can make what do we want to do here? Maybe some dotted line. But we can just like make this giant queue. We'll make it empty, right? And generally speaking, first in, first out, right? Like there's exceptions, but stuff kind of flows down through our queue. Let's remove the reversed arrowhead. Yeah. Stuff kind of flows down through our queue, right? You put it in, we'll make ourselves a little task, All right. Make ourselves a task. Okay, here we go. Task. And as we go through, we add tasks to the queue. The first one that goes in is the first one that comes out. Okay, so this is not like a stack or something. We're just queuing these things on. Okay, just add it, comes out. Add it, comes out. Right, but examples of things that are queued are basically like set timeout. Is probably the most common one, right? You're running a task, right, which is just some synchronous execution of JavaScript, and you call set timeout, and then that's saying, hey, after X number of milliseconds, roughly, it's not a guarantee. We'll explain that in a minute. We're just going to add something else and run it at that point. So we just kind of just have this running queue, right? Now, every once in a while between these tasks, the browser might be like, hey, we have our own task that we want to run. So let me see if I grab one of these. And the browser might be like, hey, what browser task? Actually, I should use a small one. Why am I using Excel here? Browser task. Let's get these smaller. Sorry, medium. All right. All right. So, because each task has a boundary, we can kind of like insert in, like there's tasks that we set up, and then there's tasks that the browser needs to do, like paint or run your event handlers, right? Like there's basically, there are other tasks other than the ones we create in here. And the important thing is because each task is a finite length, we're able to just like schedule stuff and keep it going, right? Like this is why you don't do while loops in JavaScript for infinity, right? Like this isn't parallel, right? Like this isn't like, go start a sub process kind of thing like you find in languages. You don't block in JavaScript. You don't hold the execution. You yield to our task queue, okay? Right? So I'm pretty sure everyone should be familiar with this. This is fairly straightforward, kind of like basics. And this is kind of where things were through most of the 90s and the 2000s. And then some stuff happened. I guess I should introduce, there's a couple little caveats here, because you guys are familiar with set timeout, right? This is one that just kind of uses a timer. The browser also wants to refresh or paint, right? And it tries to do that roughly 60 frames per second, so every 60 milliseconds. So there is like, I'm just going to kind of talk about a few other things here, right? We talked about set timeout, right? Set timeout. Another one you've probably seen is RequestAnimationFrame. And RequestAnimationFrame, basically, because basically every so long, let's add a dot here. Every so often, the browser will want to kind of, we'll use this as where it interjected its browser task. Yeah. Every so often, the browser's going to try and render the page, right? So set timeout just kind of sticks it in this stack, as it goes, right? And, based on the milliseconds, like, okay, 3 milliseconds, 0 will try and get it in, but you can tell if there's something already there, it's not going to run in 0, it might run in 1 or 2 or 3 or whatever. But RequestAnimationFrame is like, okay, before the next time we yield to the paint task specifically, which, is another maybe browser task that's going to come up here, try and sneak in our task, let's try and sneak in our task before that, right? That's what RequestAnimationFrame is like before the next time you paint, sneak in a task here, which is, it's a little bit different because you're starting to see that there's kind of like priority. Like if we're getting close to paint and you have a set timeout doesn't really care about paint. It might go after our browser paint, where RequestAnimationFrame will try to get in before the next one of these yielding tasks, right? So we're already getting to something a little bit more complicated. Whoa, chat's really, really quiet right now. Is this just because you got, like, I'm covering the basics and you guys are already familiar with this, or you guys like tuned out, you guys gone to sleep? Yeah, just sleeping. No. All right. Yeah, yeah, all good. I'm just making sure you're live. Whenever chat's quiet for like 5 minutes, it's like I got like a little guy around right now. He's 9 months old. If he's walked out of the room and he's quiet, he's into trouble. Not walked, crawled out. Yeah. Okay, cool. So this is sort of like the fundamentals of like browser based. Then something happened in around 2007 where like Node came out and people were trying to do like server stuff, and they were like, we really want to preempt, like insert tasks that happen before other tasks. And they kind of came up with something called SetImmediate. Now SetImmediate is not part of like I think maybe one of the browsers like IE or something tried to implement, but it's not like JS spec. But the idea Node had it was, I'm in this task right now and I'm running. I don't want, and someone else has queued some timeouts, but I actually want to sneak a task in between these two, right? Like, even though these are supposed to kind of, these are supposed to, queue and run relatively in order if they're like both set timeout 0. I want something even faster than set timeout 0 because I want to actually sneak in, right in here. I want to sneak in there, right? And there's a lot of reasons to do that because you do something in your task and then you can't run it synchronous, but you kind of want to make sure that you get first crack before anyone else does. That's where SetImmediate came out. And it as it never got standardized, but I do want to talk about it because it's important. SetImmediate is still a task, right? It is taking one of these. It's just trying to jam it in between what was already there, which is important because with tasks, there's always that opportunity to be preempted, right? Be like, oh, we're going to do a paint. You can't interrupt a synchronous task, but you can be like, I can get in front of it, right? But like generally speaking, this was like the first attempt at kind of trying to do this preemptive scheduling. And it's important because not all tasks are equal. We saw the browser doing like a paint task or handling event handlers as not being equal. Another task that is not equal is window.post message. These are faster than set timeout 0, for example. So there are, like, I remember in JavaScript frameworks, a game we used to try to play, and you guys can kind of try and answer this yourself, right? Assuming that there's no SetImmediate, or the closest we have is window.post message. How, when you do work, do you say, do the work after the next paint, right? This is kind of an exercise. The answer is actually you set 2 timers, because RequestAnimationFrame gets you right before the paint, and then if you want to do work after the paint, so you're like, hey, I want this work, but I want it to happen as soon as possible, but let the browser paint. What you have to do is say request an animation frame and then do a set timeout inside the animation frame. So like basically you can view it here as I'm kind of, our queue's a little busy right now. Let's just alleviate a bit. So I'm going to pull this one out. So what you do is you're in your task that's running. You go, okay, request animation frame, which schedules it right here. And then inside this task, you basically do like set timeout 0 or post message, SetImmediate, essentially, like the soonest you can do it. And then it will put the task here. And now you have a task as soon as possible after the paint. So there is some kind of funny little games you end up playing when you kind of play around with the timer. But this is kind of like what JavaScript scheduling looked like up to about 2012. Chat's quiet because it feels like the introduction of a lecture. Fair enough. Insert don't be suspicious GIF here. Timeout 0. Yeah, exactly right. So yeah, we use Windows.postMessage instead of set timeout 0 because it's like slightly faster. But generally, this is, if you've ever seen this code, it's kind of it's kind of an, you might have seen around it. Why was SetImmediate not adopted? Well, I think it's because of what, I think it's partially because the behavior might be a little bit ambiguous. And the problem it was trying to solve might be better solved by the next part I'm going to actually show here. Okay, but that's a good question. Let's ask, why was SetImmediate never adopted? Yeah, I was right. Non-standard Microsoft creation, but it's what does AI say? Because major browsers disagreed with Microsoft's proposal, eventually leading to its deprecation in favor of Microtask. Yeah. Okay. Yeah. Yeah. Lack of consensus among vendors, web compatibility issues. Early attempts to browser engines to make set timeout 0 behaved immediately as SetImmediate broke many existing websites that relied on small deterministic delay of set timeout. This led to reluctance to introduce new similar global timer, superior alternatives, which we'll talk about. Node found a permanent home, but its behavior there was specific to the node event loop. This created a split in the JavaScript ecosystem, and it's been deprecated. Okay. Developers are advised to use Microtask for Microtask or message channel as a polyfill task deferral. Yeah, so message channel is what I was talking about in terms of post message. Like, it's close enough. Basically, people were using SetImmediate for 2 use cases, and they wanted to be more explicit because the example that I was talking about were with post message is this one that introduces this task, right? Which is like, hey, let's try and sneak a task in between here, so to speak. That's not actually, this is not the right example. It's more like if they were next to each other. Like this was set timeout 0, and I want to sneak a task in between. But it's still a task, because if there's a browser task or something, someone could come and preempt. There's a second case is, what if you want something to basically be like it's synchronous, so it's not preemptible, right? So, and in order to do that, we need a second queue. So far we've been talking about the macro task queue, let's call it, okay? Now, there's another queue that, to my knowledge, cannot be preempted, right? It doesn't have this, like, these lines and stuff. And this is the micro task queue. And the microtask queue is, it's another queue. Obviously, you can just queue your tasks on here. But the difference with the microtask queue is that before the browser will go to the next task, it doesn't matter what it is. It could be our paint task, it could be our animation frame, any of these tasks. It makes sure to completely flush the microtask queue. So if you're in a task and some microtasks come in, doesn't really matter. This queue will be completely drained before. Sorry, let's stop doing it. Like trying to make this stupid. Okay. This queue will be completely drained before it runs the next task in here. And this is important because this task, microtask queue, can't be preempted. Some people make the mistake early on where they like keep on queuing microtasks, and they can starve the browser just as much as if it had been synchronous. Like if you just keep on queuing microtasks, the browser will not paint. You will lock up the browser. The benefit of microtasks is framework has a perfect example. What if you call set state 12 times in an event handler, right? Do you want to go and do the work 12 times? Like, do you want to let's go 1, 2, 3, 4, 5, same state, you just update it. Or 2 different states or 3 different states, but they cause the same components to re-render. I'm using a React example, but this could be signals. It doesn't really matter. Signals, sometimes you don't really care because they only impact a smaller segment of your node graph, but pretend you're React, and every component that use that state is going to, and downstream is going to re-render. If you either update the same state 4 times inside an event handler, or you update like 5 different states, you don't want 5 separate renders, generally speaking. You don't want to necessarily, like, if the user has like set timeout, like, or their own kind of time, you don't want to like yield and just like do it at some random time, right? Like come in and go, okay, now I'm going to do the work. You want it to run basically synchronously right away, but you want enough time to be able to collect all the stuff that happens during that synchronous frame. So like, this is like common thing. As I said, Solid didn't have that, so we literally had a batch where we had to wrap the call. So at the end of the batch, we would run it in Solid 1.0. And so our default was non-batching when you're outside the reactive system. But almost every single other framework, especially because they have the whole component tree to worry about re-rendering, essentially uses a microtask, because they can basically collect as many they want, do all this, like basically go, okay, like at the end, they just see, okay, this, if you updated, called set state 5 times on the same piece of state and went from, counter 1 to 5 somehow, all within a single task. Obviously, like clicking an event button can't do that because each button click is distinct. But like, I don't know why you just did a loop that went set state 1, 2, 3, 4. With a microtask, instead of seeing those distinct events, it'll just be like, okay, I've set the value at the end. It'll be like, I need to go do some work. And then when it goes and checks that state, it'll go, oh, it's values 4. It didn't see the 1, 2, 3. It didn't care. It just sees the 4 at the end. This is part of maybe an argument why React stays in the past. Side note, because until it actually runs that thing in the microtask, you know what I mean? Like, the value hasn't propagated. But I'm just kind of pointing out that there are a lot of benefits to microtasks. The reason they were created in the first place was promises, right? If you essentially have a then chain, so you await something and then something else awaits it and something else awaits it, they wanted a guarantee that stuff would basically run always not synchronous. Like, they wanted to make sure that, like, you can just open a playground right now so you can see. It's just one of the most painful, annoying problems with callbacks was that, like, if you had a code block and you were like, you guys familiar with the old callback syntax, like in Node and stuff, where you can be like value. So what you do is you'd be like, I don't know, do some async, and then essentially you get a callback like this, right? And then it would do something with value, right? Very common in this pattern was like, if error, blah, 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 right? Do something with this value. The reason I want to point this out here is that with callbacks, let's pretend this is do more async, which takes that value and then returns a callback itself. One of the challenges was we called this async, but if I remove this, we have no knowledge of whether this runs synchronously or asynchronously. Do the more things we add here actually block the main thread? I don't know. Do they do it all the time? Sometimes. This was a lot of fun in reactive systems like Signals that do synchronous-based tracking, because if someone did something that was like, const v equals, signal whatever, right? In here and in here, they had, they had like some other signal 2. Depending on if this decided to run async or not, decided on whether these got actually tracked. Like, you can picture this whole thing could be inside an effect. I mean, this is the worst code, but this is like, this is what using signals back in 2010 looked like. Okay. But this is not unique to signals, right? This is like pre-async await, pre-promises. My point is, like, what tracks? Zalgo. Like, I have no clue what tracks. Graph is such an untuned name. Shouldn't it be more like on next frame or run after paint? I know these are not great either, but what's the request team come from? Well, okay, I can explain that. First of all, it's actually before paint, which is the really kind of thing. So, and the reason it's called request is because they didn't want to promise it. Because if you request, like, let's pretend this is the paint here. If you request animation frame, and there's already other stuff queued up for the animation frame, and it runs out of time. One cool thing about RequestAnimationFrame, again, I don't know how many people know this, is it has, the callback has a timestamp in it with a DOM high resolution timer. It's one of the queues that actually keeps track of like how much like times processing, because it wants to keep that 60 frames per second. So sometimes it goes, okay, crap, I don't have enough time to run this before the next paint, so to speak. So it goes, it bails out, and then it makes sure that it runs before the following paint. So they called it request because it was a suggestion. It was a request, not an actual like promise like that it will happen. Right? So like, yeah, I just kind of to get that out there. Anyway, yeah, as I was showing earlier, if you actually want something to be after the animation, you actually have to use 2 timers, and hopefully, your request animation frame, because your timer is so quick, like it literally just calls like set timeout or post message right in it gets in there. But it is possible, I presume, with this approach to actually skip a whole paint if you're not careful, because if there's too many things in the request for animation frame and it runs out of time, and then it doesn't run your set timeout and has to run it before the next animation frame, you actually skip that whole frame and it ends up on the frame afterwards. So I mean, I guess if you really want to make sure it gets in, you kind of create like a cancellation queue. It's kind of like if you're like a racing timer. So you call, actually, could that even work? Because there's a possibility that it'd still get in beforehand. Yeah. I think it's just something you kind of accept. I mean, if you're willing to push something out past the paint, then it's not the most urgent thing. Anyway, where was I? In my Excel draw. No. Yeah. God, what was I talking about? Right before that. We were talking about the microtask queue. Starving. I actually completely lost my train of thought. All right, we're in this playground. Yeah, okay. Yeah, synchronous running. So they wanted to make sure that promises were always async. Like, so like when you hit something like this, like now do some dot then, API is a little different, but I mean, they wanted they wanted to make sure that this would always break up the like resolve. It's just because like it means that like the difference between the first time you call it and the second, like obviously like promises only run once. So, and if you're actually generating like if you actually, it should be more like that. If you're actually generating a promise, then like when I call the effect again, it's going to remake the promise. But like in a situation like this, let's say where the promise has already run before, right? So we actually, it's more like something like const something, gotta love my names, equals do some, right? And then like this. They wanted to make sure that at minimum, like if let's say we do something over here, console.log, hey, they wanted to make sure that like the first time it runs, hey will run before anything in here, right? And the second time it runs, hey will still run before anything in here, even though this promise is already resolved. They wanted to make sure that the behavior from like a synchronous flow standpoint was identical. Like, don't get me wrong, I curse it all the time that promises can't be synchronously accessed. Every framework, especially ones that do hydration, hack this. They like add extra fields to the promises so they can be processed synchronously, because like we need that to hydrate properly. But generally speaking, these are like the reason they're designed this way is so that like the same function, same piece of code that runs multiple times, it doesn't create the promise but runs a promise, will always basically from a synchronous standpoint act the same way. It was very confusing, you know, back in the day before promises, that sometimes hey would log first and sometimes hey2 would log first. So yeah, I hope you all are following why this is the case, right? This is why. And obviously this is a one of the biggest changes to the JavaScript engines ever. And people complain about, you know, old Internet Explorer, and they should. I think it's kind of fallen out of memory, right? But the biggest gift that IE 11 gave us was that one of the last features they snuck in, they didn't have promises, which everyone's like, oh, that's ancient, but they snuck in something, MutationObserver, which is a browser API to notice like if a DOM node updated. And mutation observers were spec'd to work on the microtask queue. And I don't even think they had a microtask queue in old Internet Explorer, but what they ended up doing, they might have just kind of faked it, like just like preempted in the task queue and just been like, okay, if anything comes up here, we'll for sure just stick it in and make sure it runs before we run paint. Like, I don't know if they hacked it in or whatever, but they snuck this little thing into IE 11. And because they did that, we were able to polyfill promises in IE, even though they didn't exist there natively, which is great because basically, and I've written this in the past, you could polyfill a promise by making like a DOM node, and then setting up a mutation observer on it. And this would have the right timing. So you could basically just like take some kind of function you created and then have it listen to the mutation observer on this DOM node and get microtask queuing timing. I was able to, some old app I had, that had to support IE 11. I was able to like basically support it because they snuck this in. Yeah, literally code that has nothing to do with the DOM. We just use we'd use like create a div element just to fake the timing for a microtask queue. Okay. Anyway, my point is, microtasks are a very powerful thing. Okay, so let's actually accidentally hit the wrong thing here. I want this to go away, but we have two microtask, which is probably the most kind of like, this is a superpower. As I said, a lot of people have like animations of this thing to show that like what the order things are, because every time a microtask queue is, the current task will finish, but this will completely drain and these can queue on other ones, right? If you've ever seen like promise then, promise then, promise then, it'll completely go through the whole chain of promises before it gets to the next task. So like there's obviously the explicit then. The reason is everything you return from a promise becomes a promise itself. And this is like one of those classic things. Again, just something some people aren't aware of, especially with async functions, because async functions have this funny way, and it's not funny, it makes perfect sense. But an async function, whatever, an async function, even if you don't await, even if you just go like return hello or hi, this still will resolve on the microtask when you call it. Like when you call H here, it's not going to like, you know, it's so funny because the problem is if I console log on here, this will still run first, but yeah, I mean, I could come up with some more convoluted way of showing this, and this code doesn't run because I have a bunch of broken code. My point is that this line here, console log D, I mean, it doesn't really matter because you're not awaiting this, but like this, like, and there's nothing after here, so to speak. But the point is that this this still awaits, like it. This is an implicit, almost like hidden await, right? Which is why if you actually want something to run synchronously, you don't use this. If you look at like the internals of something like create async, where I want it to either, you know, run synchronously, like say you grab it from a cache or something, or async, like, or take a promise. If it takes both APIs, the actual internal implementation can't use an async function because it'll always force it into a microtask queue. Another small detail, like cases when you still use then. Anyway, it's also why, like, have you ever seen someone do this? This works perfectly fine, but you're actually awaiting and then you're awaiting. You're actually chaining two thens, so to speak, right? You could just return, like assuming fetch returns a promise, you could just return the promise and you actually remove one microtask. It's not terribly important for most things, but when you start coming up with, because the microtask queue isn't preemptive and it orders in order, you will hit scenarios eventually, which some people probably hit this when they're doing testing on async stuff and they don't have good tools. This is why most tools with testing, like testing library and stuff, like have good tools, where you'll be like queue microtask, queue microtask. If you actually look in Solid's internals for around streaming, we have stuff like this, which seems really stupid, but it's because I have to ensure that this microtask runs after any other microtasks that might get queued during like this frame. Like it's a way of like you still might have to play with ordering here, where you're like queue this task and queue a task in it so that it comes after any other task that would have been queued by this task. It's funny. Again, you'll see these tests. They're really funny in our, especially old stuff where I wasn't using Solid's internal scheduler, where like you'll see a test and it'll be like this. It'll be like await promise dot resolve. Sorry, promise dot resolve, and we'll do it twice. We'll just be like this. Wait, promise dot resolve, and then do the thing. And you're like, why do you have to do this? It's just because of the ordering of the microtask queue can matter. This is kind of craziness. That's why microtasks are super powerful in this. But because the hope is that the end developer, the actual developer, is just going to do this. Set timeout 0. microtasks aren't for you, they're for library maintainers, usually. Not in all cases, but usually. So you just call set timeout, and set timeout 0 will always run after all the microtasks. So like, this is just your guarantee, like, hey, I'm clean. Set timeout 0 means that I've completely depleted the microtask queue. The task before me is completely done. I'm just going to run this at a reasonable time. Yeah, yes, try catch matters because, but I mean, you just write it with .catch. It matters because try catch has to have special behavior in terms of where it actually can grab. Like if you want to use synchronous try catch, you need to be using await. If you just put promise.then, the try catch has no clue what it's hooking into. It's kind of like we'll see later, like why start a transition wraps actions. Like we need, if you just do like try catch and go, promise p dot then this, well, it's not hooking into anything, right? Like it's not thenning. It's not like the try catch has no idea what this code is. It just sees, like, it doesn't even see it. Like it just goes, okay, you're putting a then handler on this, and then it runs through. There's no error. There's nothing that could possibly thing, right? Whereas you have to actually, if you await the promise, then the try catch is like, oh, in here we're actually waiting for this thing. There's a promise here. Like this is how it actually knows there's a promise. The code doesn't get executed in the block. Exactly. Yeah. I don't know how, like, it's an interesting question. I mean, there's some languages that guard heavier. Java scripting based on Java is interesting, but we don't even use it. A lot of people like, does anyone here? I mean, I do it sometimes now, but it's like there's that very OOP stance, where you could like type errors. JavaScript's usually never been that crazy, but I mean, the more complicated system, the benefit is. I know there's other systems that just like avoid exceptions or the concept. I like try catch being in the language because it gives us a way of bailing out of code, which is really powerful, right? I obviously I'm going to say that because who's throwing promises? I am. I'm not even just throwing errors. So like the whole fake algebraic effects thing, which is another topic that we shouldn't get into today. Yes, yeah. And this is kind of I think the bailout behavior is interesting. But in a sense, it is a legitimate state to be in, right? As long as you've handled it, right? A handled error is a legitimate state, and an unhandled exception is a whole other thing. So anyway, microtasks, super cool, super powerful, going to be very core. They in what we do. But yeah, it's important to understand that these will starve just as readily as if you do a do while loop. Okay, continuing. Then the next one in our timeline is request idle callback. This one isn't as fundamentally changing. This one is just like, okay, hey task, you're coming in and you're like, when do I run? And you're like, whenever you're free. So kind of stick it at the end here. And then it's like, oh, something else came in. Well, I'll just keep on bumping you back up. Request idle callback is like, whenever the browser has nothing else to do, then run me, right? But it basically gets preempted by everything, almost. So it's useful when you're like saying, this is stuff that I don't really care about. Just when you have a free moment, can you run it? Simple enough. Interestingly difficult to implement without it. Some of the we have a polyfilled implementation inside Solid 1.0 that I'm going to remove because I don't really care about the scheduler coming to Solid 2.0. But we kind of polyfilled it based on some React code that I've seen. And what they did was they basically did a animation frame, because if you think about it, animation frame is about as lazy as you can get in a generic sense. Like set timeout has no guarantees, and whenever the time comes, it will try and get in there. So the idea with the request animation frame approach is essentially using the dead letter, like pushing it basically to the end of the frame before the animation for the next thing, and then using a certain dead letter queue, it's called, like where you're basically using the remaining time on the animation frame to run some of the tasks, and then when you get to a point where you're like, hey, there's not enough time left, you just kind of keep the queue, like manage the queue yourself and go, okay, I'll wait till the next animation frame. So basically before every paint, if there's time left, sneak in a little bit of work. That was kind of pre-request animation frame, and it was an important part of actually how time slicing worked in the React scheduler for a while. This idea of like before every paint, see if there's any time to fit in a little bit of extra work. But we have this in the browser now, so that's great. And then the last one I want to talk about is Scheduler.yield, which is a relatively newer timing thing. And what Scheduler.yield does is, this is the first time out of all of these where a task can be actually running. So actually a task can be running. And what happens is, let's clear this out a little bit. Task is running and it's not done, but it's like, I'm taking a while. And what it does is it will actually stop, and then it'll yield to, let's put this back in. Let's pretend there's some other important tasks that are in here, like user events, or paint or whatever, some task that the browser does. Let's say it's not paint. Let's say it's like handle event handler, like a button click or some typing in an input field. If the task is running part way, it will go, okay, I'm going to stop. And then it will basically, get this one out of the way. It will basically go stop part way. So it's like run half the task. It will yield to the browser task. Important thing to note, before it yields to the browser task, guess what? It flushes the microtask queue, or it could be a browser task, could be event handler, whatever, but it flushes the microtask queue, always flushes the microtask queue. And then essentially it will sneak the yielded task back at the front of the task list generally. Like, it depends on what's there. If there's nothing there that's important, like more important, like that, it will just, it'll be at the front. But if there's something, basically when yield splits, it tries to find the most appropriate place to put it. If there's something more high priority, it'll put it afterwards. Otherwise, it'll put it right at the front of the list. But this task that's been split now basically yields to the more important tasks. And then the process goes, okay, gets there, yields, flushes the microtask queue, runs the higher importance task, finishes itself, and then continues on with the macrotask queue. But that's essentially what Scheduler.yield does. It lets certain higher priority, like user input based macro tasks run before the current task finishes, but it makes sure that the current task still keeps its place in the queue, so to speak. And as it incidentally, it also flushes out the micro task queue. So that's kind of the JavaScript event loop in a nutshell. Any questions so far? See, hopefully now that you all are experts in this, the rest of what we have to talk about today is going to make a lot more sense. From microtask yields is it requested in the next follow-up task? Good question. Yeah, that's a good question. Let me think here. What happens to the microtask yields? I have to assume it flushes the it would have to. Imagine what happens after the yield becomes basically a macro task. So like it would have to flush the rest of the micro tasks and then run the higher priority thing and then continue the rest of the micro task as a macro task essentially. The thing is, once a task is running, I don't think it's aware of its identity anymore. Like I could be wrong about this. I don't know the internals, but like conceptually, once it's been picked up, like this part doesn't matter anymore, right? So what queue it came in doesn't matter. Like once this is running, like it doesn't. It goes, okay, I hit a yield, so it goes, okay, I'm gonna take the rest of me, the second half, the part that doesn't run, and then I'm gonna stick it in here. Like I think that's essentially the way it works. I could be wrong, but that's conceptually what I guess. I mean, we could probably ask AI. What's request idle callback for? It's just for stuff that's really low priority. This is what we used to use, or like the fake version is what we used to use for transitions. When you're like, hey, the stuff off screen, only do it if there's free time to do it. Like we'd be like, okay, main task stuff that you're animating, fine. Stuff that's in a transition lower thing, let's just whenever you got time. And I'm going to show it again today, actually. Yeah, the end of the queue is just if it's more like if there's just too much work going on. How do you say like this is the least important thing? What if you yield scheduling microtask? Does it then force the next macrotask to run before the next micro? No, I doubt it. Let's find out. I mean, Google could be wrong, but let's go. Scheduler.yield in a micro task still flush micro task queue. Huh, apparently I'm wrong. Inside a microtask does not cause the event loop to flush the microtask queue. Instead instead the continuation of the function after the yield is scaled as a new prioritized macro task. Okay, yeah, well, that's true. Effectively breaking out of the current microtask processing. Okay, I got that right. And allowing the browsing thing. But what about the existing stuff in the mic? Yeah, yeah, maybe I used the wrong term, but listen here, microtask queue draining. The event loop specification requires that the microtask queue be completely emptied after the current task, macrotask finishes, before the next task of rendering occurs. This process continues, right? So this is saying what I thought it would say is that the continuation gets queued as a macro task, which means that you would have to flush the micro. If this is true, you would have to flush the microtask queue before the continuation of the of the of the previous microtask because it's no longer a microtask, it's a macro task. I don't know for sure. I mean, I don't know if I want to spend the time right now to make an example to test this, but my guess would be the way that I described it, even from reading this. It's if the tool to seed back the main thread, then you would have to drain the microtask queue. So drain. This phrase is different. Yeah, I think AI is confused here. In fact, the continuation runs the macro task specifically to give the browser a chance to perform other, including processing the microtask queue. No, it doesn't drain the microtask queue because it yields to process the microtask queue. Yeah, I think AI is confused. Scheduler.postTask. My guess is Scheduler.postTask. I'm not as familiar with that, but I'm guessing it's the new post message. It's probably a higher priority macro task. Okay. Okay. Cool. Yeah. This is fair. This is fair enough. Yeah. Yeah. So this is how you define the the macro tasks. So yeah, you're right. This is important. I I didn't realize this was in user space, which is freaking awesome. Just a side note. So yes, I would consider this very important. Sure. Okay. Let's talk about Scheduler.postTask, because Scheduler.postTask is the other piece that kind of goes hand in hand with this, because I said a browser task is high priority, but you could also queue tasks yourself that are high priority. Keep in mind, they're not microtasks, they're macro tasks. So this is how you can say, look, user blocking, user visible, background. So right away, you can see that there's 3 different priorities here. User blocking is probably the highest priority that always preempts. User visible is, yeah, and I'm gathering set timeout is probably considered background generically. So this is actually probably, these are basically 3 different versions of set timeout 0 in your mind, right? Where this one is like SetImmediate, user blocking is SetImmediate, and then these are like 3 different scales of it. So this is, in a sense, this is the actual, I said there's 2 different uses of SetImmediate. There's the microtask version, and then the full task version is this. This is probably the equivalent. If you got the most blocking macro task, this would be it. I don't know if user blocking is higher than paint, but I imagine that inputs like typing keyboard is at user blocking height. Paint is probably at user visible, and then background is like set timeout. That would be my guess. I do not know for sure, but yeah, this is a good question. How about making your own queue and wrapping out promise like a managed steps when you're yeah, I mean, there's benefits to pulling it into your own timing. This is yielding to the browser. You still have to yield to the browser if you make your own timing. This is what I was describing earlier, how React used RequestAnimationFrame in the past to be able to schedule their transitions. This is an example of it. If you look here, microtask queue on npm, or queue micro, what's it? What's it? Let's go on npm. Not queue microtask, microtask queue. You'll find a library that barely ever used. But this was my original polyfill that I wrote to use MutationObserver so that it would work back in IE. Last published 9 years ago. No one uses it. But the way I managed this was essentially I collected all the stuff, right? You could build promises on top of this essentially. And then when the MutationObserver fired off, I'd run the queue myself. But yeah, I mean, what was cool about this is I removed a lot of the browser overhead, because instead of scheduling like a billion timers, I only scheduled 1 timer. So there was also a performance aspect of why I did this 10 years ago or whatever. It's funny to do write tests. Oh man, wonder why no one uses this library. Oh man, I mean, anyway, okay. I think the most important concepts to walk away from here is that, like, there are 2 major queues, and this queue is actually kind of simple. The microtask queue, it was literally just like send it through, queue it. the macro task queue or the main queue is complicated as hell and has all these scheduling rules to kind of get around stuff. The microtask queue is like the bailout queue. It's like, okay, whatever you can't manage in a reasonable way here, let's make sure this happens. Like, this is like super immediate. This is basically like microtask queue. You can think of it as like, we wish we were synchronous, but for reasons we aren't. And then the macro task queue is like the actual complicated scheduler. The tests were never written. No. I have a few libraries like that. One of the, I don't think we use it. Oh, no, we might still use it actually in Solid's HTML, like tag template literal thing. I came up with like an HTML parser for breaking up tokens so that we could like get basically tag template literals. A lot of people obviously use the browsers built in to do that now, but like I wrote the thing like 8 years ago when I was doing the original templating stuff for Solid, like even before I landed on JSX. Anyway, I don't think that library ended up with much in the way of tests either. Anyway, okay. I hope the gist of it. Okay, so now that we've done talking about this and you've hit the like button on the channel because, on the video to help, and possibly subscribed at this point, we're going to talk about transitions, right? A bit. But before we even I think it might be better, instead of like saying like, here's transitions, how they work, I'm going to show you a couple of the examples that people made to show like why transitions are good. And then we're going to just try and solve them without even having transitions. And we're just going to like kind of work through it, like what's happening and whatnot. So the first example I want to get to is, I wonder if if I go on my Blue Sky timeline, will I eventually find it? Let me see, can I go on my profile? It's been a while. I should have pulled this out before we did the stream, but a while ago, it's around the time we talked about this demo with, I want to start here for a reason, but with Ricky Hanlon, because we were having a bunch of really great great discussions around the stupid demo. I don't know if I have it. I want to pull out the old Million.js. I did this one on stream before. Million.js versus React concurrent. I'm never gonna find this stupid demo, am I? It's a Dan Abramoff spinner one. You know what? I think I saw a version the other day where someone did it with Solid. Just sorry, give me this bookmarks. Can I find it? Oh yeah. Okay. Cool. You guys all seen this demo before, right? I'll explain that in a minute. Kind of a silly thing, but you'll see why in a moment. Okay, so this demo is infamous because the Solid implementation actually is not optimized here exactly, but I think I should be able to still show this example. If we go up to some stupid amount of rows, like 10,000, which is going to take forever, and you remember this will, when I click on this, there will be a little gap, but what you're going to see is I'm going to click on this, and then I'm going to lift my hand, and then 2, 3. You see this updates right away on the button because they opt into tearing here. But generally speaking, when I click the button, there's like this delay, right? And if I go into the Solid version, the delay is shorter actually. It's not just because of the tearing, the delay is slightly shorter, but it has that same kind of gap, right? The reason no one does that, but basically there's a slight overhead on React interrupting, which causes it to lag more. So when I click it 1, 2, 3, 1, 2, 3, 4. Actually, what's going on? Am I too high up? I'm not even. 1, 2, 3. 1, 2, 3, 4. You can see that it lags like slightly more up here, but the results show up shorter period of time. It's an interesting trade-off, and I'm gonna this demo came out and it was trying to show like this is a dumb framework is more blocking because like this it updates faster, click 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 click, but it's blocking your animation, which you want to be smooth. Whereas if you have React's concurrency here and I click 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 click, it's not blocking quite as much. I mean, it's still blocking pretty badly, but me and Ricky talked about this, how this demo is basically a complete loss because like there's just no winners here, right? You're trading two trade-offs. Either you block and have the whole time of everything happen faster, or you don't block, but then the whole thing takes longer. But if you look here, when the workload gets high enough, they all kind of suck. And the reason for that, I'll show in a minute, but let's look at the code here. Okay. Right. This demo is honestly kind of a waste of a demo, but let's see, do I have the React version in here? I think this will help us understand what's going on here. Does this not even use a transition? Where's the transition? Is it just using deferred value? Anyway, the point is there's the arrays of rows, and then you're just setting a count click, and that click causes basically every row. The array stays fixed, at least it's not getting bigger, but every single row has a count, the count. So it updates every single row. There's also some fake extra work here, which I'm gathering they have in there to test the React compiler or something. Because for React, this would kind of suck if you had to actually, every time you clicked it, made a bunch of extra work rendering. Obviously, Solid only runs the component once, so this isn't a problem here. But generally speaking, the thing is, this is like, it's a shallow array where every single row updates. This is basically, if you're comparing signals to like a VDOM, this is like the most beneficial to the VDOM benefit, because there's nothing granular about this. Like if you have to update all the rows, you have to update all the rows. You know what I mean? Like, yes, there's elements you have to take care of, but conceptually, if you have a good memorization, the overhead of the signals existing and communicating each of those 10,000 rows independently versus just running the one thing, running just a for loop and just updating the one thing in each row, technically signals should be either equivalent or slightly worse in this scenario. So this is basically React's best case scenario, and because every row updates. And the thing is, the truth of the matter is they both kind of suck. And the reason is because this has nothing to do with the framework, this problem. No, it's only use deferred value. Oh, this one. Okay, you got it for me? Thanks, Ricky. Give me 2 secs. Let's see if I can pull this up. No, it wasn't that one. Yeah. This is sorry, the one you shared was the. Sorry. This is the what I call the IO one. I love this example, by the way. This is this. The time slicing is the one that we talked about, where we said that it's kind of a useless example. Yeah. The problem is sorry. Sorry, getting back to where I was here. Yeah, sorry. In the demo, you have to uncheck use void to see the lag. Yeah. Well, right, exactly. And I purposely unchecked use void, which we'll talk about in a minute, because the reason for, if there's lag, yeah, let's just scala draw this, okay? next to Scheduler. Okay. So what's happening here in this silly demo? If you've got like a timeline of the work, each bar, let's go back to this single solid stroke. Okay. And let's not make it sloppy. Let's make it tight. Okay. So the first part is the event. The user clicks it. And this is going to be so small that I'm not going to be able to put it in here. So you guys will just have to know that this red here is click. Okay. Then there is, let's add the next thing. Our next thing is going to be green. And the green is going, the green is going to be our event handler. And our event handler is where we call set state, okay? So I'm gonna duplicate this so that they're the same size. Green, green. And then the next part is like this. I think I'm even being generous here. Maybe like this, where it's blue, and the blue is framework does work. As in the framework is doing like going through and updating all the signals, or going in and doing like rendering all the React components, right? And the length of this might differ between different frameworks. Some might be, let's pretend that in Solid's case it's like this, even though I said because of the case, I actually think React and Solid are probably fairly equivalent here. Okay. But let's pretend like, this can vary a bit, right? And then the next one, which we're going to do in our brown, is the DOM, which takes up this much. Okay. DOM updates. So actually like updating the DOM. Okay. That's roughly the breakdown of the work in this demo. Okay. And now if they've got a trick here in this demo where they use void rendering, which means they don't really paint it. They stick it like in a portal in the head or something, I believe, where it doesn't participate in the thing. Like basically if I click void rendering, the rows disappear. Now there's no rows. And what this demo is like, okay, smooth, and then here, oh, not quite as smooth. See, actually it is still smooth. Yeah, I mean, maybe you have to up the rows more. Like, you're kind of like, well, if you're not, low blocking time, low delay in updating UI, responsive while updating. Low blocking time and low delay in updating UI, unresponsive while updating. Yeah, okay. Yeah, I mean, maybe we have to put more rows in, but like theoretically, you could understand why there could be a benefit. Because what this does is, what if you got rid of this, or let's say reduced it down to about here? That's what that example's doing. But I'm actually not seeing a huge difference here, unfortunately. But the problem with this whole thing is, okay, let's see, can I line these all up beautifully? Now pretend, let's wrap this whole thing in white, transparent and white. Okay, so this is our work unit, okay? Yes. So like, this is why both demos kind of look like garbage, like you're just trading one timing for another. But there is some benefits to time slicing. I want to talk about this. Now, when there's one and we see that lag, it's not like they kind of look similar. The problem is what happens when more than one come in, right? So let's pretend we have that, and depending on the timing. Now, if let's use our knowledge of what we just learned in terms of scheduling here to figure out here. I'm going to move this one down here out of the range. So let's start here. So if our second click happens here, well, we can't interrupt the DOM doing its updating. So even, oh, okay. Sorry, where's my Scheduler? Did I accidentally back out of it? Okay, good. Okay, sorry. This is wrong. I should take this out because the click itself is not within our workflow. The click itself is the browser. So let's take it out here. So if the second click happens anywhere in here, right, this event, the earliest that we're going to do any more of the work is right here, right? Right? So you kind of start seeing like the basic problem, right? Because let's do this again. All right, I got to delete it. It's sorry, it's this is our unit that we want to copy. This whole thing. So wait, you know what? For sake of us doing this, I'm going to shrink this down so that we can do this easier. Because I need to show this. Go away. Delete. And shrink this down to about here. Beautiful. Okay. So okay. First one. Second one, click happens here. And honestly, third one, click happens here. This is kind of the problem with the naive approach, right? Because you click, let's say you click multiple times while this is doing the DOM work, it's just gonna not be able to process the event handler because like this is the classic like queue microtask problem. Like you now if the between the event handler and when you process there's an animation frame, things change. But if we just assume that when you call set state it queues a microtask, which isn't interruptible, essentially I guess and that the work from the from the framework work to the DOM work all happens basically synchronously, which it should. That's important because you see this and it's kind of terrible because you click 3 times. You could have canceled the work, but you're doing it's going to take you all the way to here to finish. Right? This is the really naive approach because it does DOM work here that it's literally going to throw away. But the problem is, and this comes down to framework design, if the blue and the brown have to happen synchronously, generally speaking. You want the blue and the brown to happen together synchronously because you want those guarantees. If you broke the brown apart, part of the screen is going to show one number and the other part's going to show a different number. If you don't finish the blue and you chunk up the blue and brown parts, you're also going to see the same kind of tearing. If you, generally speaking, you can choose the delay when you do the brown, for sure, but the blue has to be completely finished before you do the brown, and you have to do the brown all in one chunk. And because it's like once you start the brown, you're kind of in trouble. Now, I could see that if you got to the end of the blue and you realized like this click had already happened, you could do something, right? But generally speaking, this is what the naive framework does right in front of us, right? Only if the user mashes furiously to cause things to overlap. Yeah, right. But that's the point of this demo, right? So what can we do here? Right? What can we do here? Now, as I said, assuming we can't interrupt the brown, one thing that we could do, like one thing that we could do smarter is make sure that all the green runs first. So like, what if this wasn't one consolidated unit? What if there wasn't a queue microtask, there's a request animation frame? If we did that and we pulled the green out, sorry, let's try this again, and we pulled the green out. I'm going to copy this. We'll keep the naive thing on the screen. Okay. So this is naive. And let's call this one animation frame DOM. Okay. So the first thing we could do is kind of pull the green thing out. So I can click into it. It's going to be so small. Let me see if I can click into it. If we pull the green thing out, so it doesn't happen as part of this, then in theory, we could possibly so annoying. It's fine. I'll just delete this one. And I'll grab this one. Actually, I don't need this. It's possible that we could do this. We could do this. And then essentially, because the framework never saw the update, do this. So this is our first win, right? If we can process all the events before we do any framework work, we like this just queues it. As I said, if we use a microtask, we're kind of stuck. But if we use an animation frame, framework. Animation frame. It's actually not the DOM frame. Framework work. We already have a win here, right? To be fair, in this kind of basic case where the clicks happen at this time, this is honestly probably the best thing we could do when the clicks happen like this. There's another option here. Now, I mean, and which is kind of where I wanted to kind of get at is, let's move this down here. Let's move this down here for a second. The other thing here is, okay, this is like all we can do essentially if the work is happening during the DOM work. But the other timing is click happens during whatever, during, I'm just like sucking right now, during framework work. Okay, because another thing is, what if the click happens earlier? Now, if the click happens before, and we've split it like this, if the click happens here, let me zoom in again so you can see it. If the click happens like at the same time as the green, like sneaks in between, then we're in the best space. But let's do it. Click happens before framework work. Sorry. Let's show what this scenario happens. I'm only going to be able to do this with one, so we won't worry about having two here because like the timing's too quick. But if we kind of go in here, sorry, I have to. This is the only one that I did that was not separated. So, do this. Sorry, this. Here. click. This goes here. This goes here. Sorry. Okay. Hopefully you're still following. But if the click happens here, it is conceptually possible that we could essentially because it's outside, do this, and then actually I just delete this. We don't need any of this. It's funny. The reason this is so hard to draw is the same reason it's so hard to actually do this in this example, because the amount of time is passing here. We could do this, right? If you took the same kind of thinking, if this is clicking during the DOM work, but if you somehow manage to click in that very, very small before the framework works, this set state could happen, then this set state could happen, basically preempting it, and then you could do the work, right? What happens if we see but the problem is, classically speaking, in our naive example, if we took this original example here, sorry, I'm going to need to, I want to make sure this is in the right spot. Okay, yeah. This is so funny because it's so tedious because it's so small. What happens if the click happens during framework work? Okay. Let's take our original example here, actually. That's why I updated this one. So before framework work, we're golden. If we do animation frame, then we can improve stuff. And to be clear, Solid 1.0 is completely synchronous, and most Q microtasks are doing it, so they don't actually get the advantage of this because they don't actually run this way. I think some frameworks do run this way. But I want to show what happens during framework work. So it happens bang right here. Well, unfortunately, because these get tied synchronously, this essentially the rest of this timeline doesn't actually change at all, right? I'm going to remove the second click just so that the last two are comparable, but essentially, or the third click, you're still basically here, right? You only get the benefit if the click happens before the framework does the work. If the click happens during the framework work or during the DOM work, like we're going to get jammed up basically. Well, I mean, in this demo, the DOM is super slow, which is why there's a lag. I mean, you can, when I put the void rendering on in this demo, I click it, I wait for it. Like, I can definitely click this twice before it updates. Right? Like, did I not add enough rows? Let's go 20,000. Right? I can definitely click this before it updates. See, this updates fast, but look at this one. This is because it tears. Look at this one. I mean, even here, it's because the challenge is because this one's tearing, where this one's not tearing. I can show it better on the solid version because it's not tearing. I can definitely click this multiple times, click before this happens, because the DOM work. What's happening here in the React version here is it updates the one element first, and then it defers the rest of the work here, which is why it's responsive. But you could also accomplish this in the solid version without anything fancy by just decoupling the signal. Like a very basic idea is have two signals. one signal updating the button and one signal updating this table. And then when you click the button, have the first signal update the button right away and have the other one call it in a set timeout. You would get the same delayed thing without doing anything fancy, right? It doesn't really matter in this example. I'm not saying you should do that. I'm just saying it doesn't matter in this example because the size of the DOM update is so freaking huge, right? Who's interrupting? But what I'm getting at is the base JavaScript has no interruption. Like there's no interrupting. That's why we went to the microtask. You're basically you once you're in the sync execution, there's no interruption. But let's get here. The DOM updates, this brown thing. I mean, the browser might have some scheduling side in its world that I'm not talking about here, you know, like little things like separation between layout and paint and all this kind of stuff. But like, it doesn't matter. The brown section, the immediate part is rather large. And what I'm trying to get at here is, if a click happens during the framework work, you're kind of still in the same boat. The only way you win here in this example is if you can really win. Like, first, you can win if you defer the framework work. You split it from like calling the event handler. But otherwise, like you basically only win if you can click so fast that the framework hasn't even picked up. Like essentially, like in less than like a millisecond. Like, you know, like it's that timeout zero timing. So what does time slicing have to do with this? Well, what if you could interrupt the framework work, right? So this is like no time slicing. Now let's add time slicing. The idea with time slicing is, grab this whole thing. The idea with time slicing is, now this is where I'm just going to get rid of my whole thing. The idea with time slicing is, the framework sees the event click, so it shrinks the blue down thanks to the event click that happened while it was working, right? And then it grabs this, or sorry, it grabs this, runs that, then it runs the full that, and then it runs this. So we'll just get rid of this. So you can see that by interrupting the blue when the next event comes in, we can basically get the same impact as before the framework work. It's a little bit longer because it has to redo the blue here, like part of the blue, because it interrupted it. But what's cool about this is that we kind of end up with this kind of same timeline, right? But you start seeing use like Scheduler.yield or something. Like in the blue work, the framework controls its own queue of stuff. Like it queues a bunch of work and it gets partway through the blue. It hasn't impacted the DOM yet. So it's like, it just knows that it's like rendered your React components. And then it's kind of like, okay, I'm doing some work. And then it's like, oh, let's like maybe it's rendered half the components. And then it's like, oh crap, DOM input. Throw that away. You know, yield, you know, let the browser do it. It gets a new set state. And then it doesn't necessarily have to throw it away. to be fair. Like, you could keep on going. But when the new set state comes in, it goes, oh, actually, what I was doing before doesn't matter anymore. So it's like I'm going through some components. Oh, something more important comes in. So every X amount of milliseconds, I'm going to yield to the browser while I'm running my Fiber, whatever React internal thing is. It gets to a certain point where it's like I've run some components and it goes, oh, let's pause. Let's check. Oh, there's something more important. Stop. Then it runs the event, sets the state, and goes, oh, I actually have to re-render these components anyways. So old work thrown away. Continue, does the whole re-render, and then gets to the end and finishes, right? So the blue can be interrupted because the framework's aware. The brown cannot really be interrupted. So I'm hoping you start understanding why this demo is terrible. Like, it literally shows nothing, because it could show if a framework uses RequestAnimationFrame to handle the difference between when it calls the event handler code and the set state. But guess what? I mean, I'm not suggesting you do this, but you could do this yourself. Inside your click handler, you could say RequestAnimationFrame set state. Just throwing that out there. I'm not suggesting this is the way you want to do it. A lot of frameworks use microtask because they want to keep those guarantees. Because it's one thing for the user to go, okay, I want to use a set timeout, or I'm going to schedule stuff. You understand you did it. But if the framework starts acting unpredictably, like because your set timeout starts sneaking in between you calling set state, you get inconsistent. I don't even think React necessarily uses RequestAnimationFrame. I'm pretty sure they use microtask. But it doesn't matter here because they can interrupt with the blue, right? Like, so they can do this. So anything that happens before or during the framework work, they can essentially end up with this last picture with their time slicing, right? But if something naive like Solid, you're going to end up with this, generally speaking. Like, even if we shrink the blue a little bit, the problem is, in order to see the difference in this demo, like in order to actually see the difference, like actually see the slowdown, we have to crank the rows so high up. And what does cranking the rows do in this demo? It just makes the brown bar longer. It makes the blue bar longer too. But it actually, even if it was linear, and I'd say it actually makes the brown bar exponentially longer, but even if it was linear, like they'd added the same amount to both, the brown bar is basically running away with this thing. So the more we scale up the nodes doesn't actually prove anything. It just, all it does is, it makes the length here that's interruptible slightly larger, but more than likely, I'm going to be clicking under the brown section of the timeline, right? React currently throws away interrupted work. If it didn't have to do that, it would actually help that demo. Yeah, I agree. Like, if React could continue but all that would do essentially is, in this demo, again, it's only the blue part. It might only help the tiniest bit, because some of the work does need to be redone, because like in this demo actually it wouldn't help because they're all the same count. So like all the nodes you already worked on, you have to redo anyways. But in a different demo, I could picture where this mattered. But because the count actually impacts all the nodes, you have to redo all the work you did anyways. In general, React's interruption, having to redo all the work, is perhaps, prohibitive. It's tricky. I mean, one of the cool things that we've been working on with the Solid 2.0 reactivity system is using a heap so the work gets sorted. But I mean, it's the same problem when you get to this. Like, so, and technically because the reactive graph is not the rendering, like we don't have to re-render the components. We only have to like propagate the data. So but this demo, again, it wouldn't help us because the topmost thing in the reactive graph is the thing that re-triggers, and you re-render, you re-propagate the whole thing. But in a different world, the fact that we reuse our nodes instead of re-rendering them is a slight benefit. React is looking at doing that in the future as well. But this demo doesn't even actually get to leverage that because it literally updates all the counts. And as we scale it, we just make the brown bar longer. So this is the most useless demo ever for showing the value of time slicing. What it does show you, though, is the difference of feel between something lagging and something like something being non-blocking but high latency, and something being blocking but quicker updates. And since in both examples this bar gets chomped up, unless you're clicking jamming it, you probably are going to prefer the blocking shorter than the non-blocking less latency. That's my perspective from this demo. But I honestly could go either way. This demo sucks. And I don't know where this originally came from. I know Million did something like this. Is this Dan's fault? I don't know. This whole radar thing and CPU thing is just like, everyone who started using the stupid radar thing did examples that were basically large brown bars, which is like, doesn't do anything. And then they're like, look how it handles these large brown bars. And you start going, like, they're the kind of things that, as I said, someone literally putting request animation frame in a click handler would get you the same results. Do you know what I mean? Like, there's a lot of benchmarks like that. I think I wrote an article years ago about how to cheat at benchmarks, and or like types of, God, let me look at Medium. Maybe that's good reading for someone. View profile. Stories. No, not drafts. Scheduled. No, published. Sorry. I haven't worked on Medium for ages. I had one of understanding JavaScript UI benchmarking. Here we go. 2019. Oh, it's a member only story? God, why do I keep this stuff in here? I'm sorry, guys. Anyway, it's probably because I published it in JavaScript in plain English. I published it on publications and they made me put my stuff behind walls. It's not like I'm making any money off this stuff. Okay, but there's a part where I was talking about different benchmarks, right? And we've all seen that. But animation benchmarks are ones that have like this one where this radar or this Sierpinski, or the oldest version is the actual one of the you guys ever seen this one, Circles benchmark? Ember and Knockout had this old bench back in the day. Here's for fun. This is the oldest animation benchmark. And the funniest thing is everybody's really good now except like Backbone. Like it just sits there and spins a bunch of circles. 5 milliseconds for Backbone. Okay, how's Inferno? Ooh, guess what? Also 5 milliseconds. Knockout? Oh, 5.3 milliseconds per loop. Okay, it's a little... I mean, I don't even know if lit. 5. So Knockout was a little bit slower. I guess it reacts to them. How was Preact doing? Oh, around the same as Knockout. React? Is this one going to be super slow? No. 520 actually beats up Preact. Is this old solid one good? I don't even know. About 5. Okay, it's about the same as Inferno. Solid with proxies? Oh, about the same as, like, basically, how about Svelte? Old Svelte? About, ooh, yeah, about the same as Solid. Surplus? Also about the same. How about Vanilla? Raw vanilla JavaScript? Oh, slightly under 5. We have a winner. My point is, this benchmark used to be a big deal. It's literally doesn't do anything anymore. But this is the classic animation benchmark. There's only so many types of benchmarks, and when we talk about this, like transitions and time slicing, their animation benchmark, I'd say what to expect. These traditionally cater to reactive DOM libraries over virtual DOM libraries, and mutable over immutable data. A similar technique was used for MobX versus Redux comparison. These tests are usually too extreme to be considered real world, but they do give visual idea how libraries degrade as browsers get overloaded. Watch out for it. These benchmarks test scheduling over it, so implementations using different methods make the biggest difference. Things like RequestAnimationFrame, promise.resolver, request.callback make a much bigger difference than most things the library does. These are techniques anyone can use. A lot of these tests are from an earlier time where these techniques were not expected, so implementations can make certain libraries appear quicker than others purely by using these techniques. I had the right conclusion 6 years ago. Okay. Yeah. I mean, it's compelling, right? It's the drawing one. Apparently, this is like the demo that the React team did to compare signals to to React's update thing, except they put the whole thing in one signal essentially instead of using stores or doing it fine grained. So it's like, yeah, MobX should be faster on this test because it's more granular. It's just, it just conceptually, it's anyway. It depends, I guess. Like if what this is overloading is if every cell is a component, then you're basically just testing the speed of Redux's connect middleware essentially versus MobX's signal notification thing. In an actual granular system, you could get even more benefits by like going directly to the DOM. Yeah. Yeah, still kicking around ideas of scripting selector. That's true. Yeah. I had some great chats with Mark Erickson. Who, for those who don't know, he's the maintainer of Redux, and kind of looking at this because these problems are kind of fundamental, right? But it is the classic immutability versus mutability kind of like selectors versus reactivity question, and like can each learn from each other? But it is kind of funny because a lot of times these tests literally come down to, oh, I put a request animation frame somewhere, and it's because in order to show it's because the load is generally going to be the DOM, which means that you end up a lot in these scenarios where the brown bar is absurdly long, and we're like doing this. Don't get me wrong, most benchmarks, the brown bar is absurdly long. It's kind of interesting why in stuff like the JS framework benchmark, where the brown bar is actually the longest part, we actually see benefits for fine-grained things over VDOM, and it's because with the slowdown thing, they really just blow up the blue section on these kind of simple table tests. But like when you have async involved like this, where you're like, we're talking like multiple tracks, it's how do you combine this blue section with this blue section? You know what I mean? Like that, or like this blue section with this blue section. Like how do you count that? I think that makes it a lot harder to measure, where it's like really easy to count the whole time, like start, end. But like counting the specific tracks of performance is a lot harder. And the problem is, even if you do that, let's say I count all the blue, but let's say the blue is shorter, but then the brown is longer. When people actually look at it, they're going to be like, yes, this is faster, but I'm not seeing it, so who cares? So like this is why I'm not like this whole, I should put a header on this whole section here with Excel. Let's do this. This is, what do you want to call this stupid demo? Radar demo? Yeah, let's call this radar demo. Radar demo. I've talked about this on stream before, but you kind of understand, like I was going to go and actually make a solid implementation that was faster and stuff, but I can't even get a good slow baseline to work off of to actually doing it, because by the time I push the thing far enough that solid is like slower than React looks like crap too. Like it's just like there's no winning at this demo. Like like this is, and it's because the blue part is so small. Yeah, which brings it to here. This has been one of the challenges, because it's like, when does the blue bar actually get large? And the answer is, I mean, this is where people make like snide remarks. So it's like when your components re-render over and over again, like people like giving little jabs at React. Like this is where the whole they're solving their own problem aspect comes from. But the blue bar becomes long when the computation gets extreme, and when end user code is involved, not benchmarks. Like it's very hard to make the blue bar long in a benchmark, right? It's not something you can just go in and go, guess what, guys? Blue bar, let's turn it up. Usually. You can do it artificially, but you can't do it through anything real, which actually brings us to our next example, the actual good concurrent demo, or at least in the past good concurrent demo. Because the answer is, In real life, it happens, but you're never going to see it in a toy demo. It's going to be caused by some weird interaction. People can get here accidentally by causing too many re-renders, but generally speaking, this has been my problem. I added time slicing, like React style time slicing, to Solid in 1.0 as an experimental flag, and then so I could test it over time. And I never ever saw. And it's probably because of the apps that I've been used or playing with, or the demos or the stuff I've got my hands in, not some I just never saw a use for it generally speaking. Like in the small place where you're like, okay, there was a benefit there. You're just like, so what? Like it wasn't like a defining thing. Like if you want to make this work better, like this example in front of me, just make the DOM work more reasonable. At 20,000 rows, I think we can use virtualization, right? Like we're kind of at an agreement here. Like just your problem here is the brown. That's not changing, right? So like the framework is not the problem. See, even when you sort 20,000 rows on the client, the blue, the sorting is blue, and then a lot of the work is also brown. The brown is actually still huge in there, but yes, like this is what the JS framework benchmark will kind of test, but like not unless your sorting algorithm is really naive, which in React's case it is naive, because I think they made a call. They're just like, why do I need a crazy reconciliation algorithm when literally you should virtualize at the point this matters? Like, okay, if you look at the JS framework benchmark, the one place that React, you can tell there's like a split. There's like guys who have smart, this swap, it's the swap rows, which is the closest to sort. It's literally just like switching 2 rows near the end. There's like a wall here. You start, and all these things, this is not a gradual climb as you get into slower libraries. You start this thing, and then you'll start seeing these spikes. Oh, what's this one? 97, 96. Okay. Those ones are really bad, but what you'll get to is everybody having these smart ones around 13, 15 milliseconds, and then you'll get to here, where you're like, Imba, 25. Angular, no zone, 25. Angular, 25. Right, which is the middle ground. And then you get into React hooks. And where's vanilla React? It should be in here. React hooks is basically vanilla React, right? And then where's React compiler? It should also be right next to it. They're basically the same in performance. React hooks. Can I find the compiler? Oh, actually the React compiler has... Oh, this last run it went slightly slower. I mean, whatever. It should be like, it doesn't matter. React classes is here. React hooks is like, my point is you'll get to here and you'll see that it's 103. So basically there's frameworks that are 13 milliseconds and there are ones that are 100 that do the naive like React. This is just like, it's a choice. React could do a smarter reconcile if they wanted to. They just don't think it's worth it. So if I remove swap rows from the benchmarks, how does that change stuff here? Well, I mean, the front of the graph, it doesn't really change stuff all that much, right? Solid and svelte, and this is a very crowded space now. It's funny, back in the day, you look at the old charts and it was just like 3 of us. Now it's like everyone. But my point is, where does React sit if we remove this benchmark? Okay, so we have preact. Yeah, okay. Yeah, 145. I don't think that actually ended up changing stuff. It actually moved React ahead of Angular. Usually React and Angular are very close. Oh no, actually there's a Angular right here. Never mind. Angular's usually they're right next to each other and they've been keeping lockstep over the years. But then I think Angular is slightly pulled ahead recently. But yeah, I mean, but if you look at this, and I look at the React implementation, there's nothing really slow here. There's a bit of a release timing because the memory is a little high, but like everybody's green, pretty much. Like obviously not as green as down here, but you kind of get what I'm saying. Like, honestly, that's probably the biggest difference between JS frameworks right now in this kind of benchmark is the row sorting. Yeah, I mean, again, there's a reason these tests exist, right? Because the idea is if you put a big enough load on something, you can kind of anticipate how it might scale in reality, but this is not actual reality. So yeah. With custom, yeah. Well, the logs after, yeah. A lot of the benchmarks have been using like the tools that are coming in the browser and stuff. Like this benchmark does a good job in terms of keeping itself out of it. Stefan is still working on it, notoriously, like constantly trying to improve on it. So like it runs actually in the background as a process that spins up isolated Chrome instances and then clears it, does warm-ups, and then like isolates the part of the actual timeline to actually do the measurements. This is one of the best benchmarks out there. But all that being said, brown bar, right? Okay. I mean, it does have impact. I said that doesn't matter much because of the scale of things, but like 245 milliseconds to show a page with lots of elements on it, let's say, or 250, and if you sorry, scroll this way back to wherever React was. React. Yeah, I mean, where is it? React hooks 400. Like it is suggesting that in this case React takes almost twice as long, 66% longer to show your content. Like that might scale up. That might make a difference in snappiness. 200 milliseconds might be noticeable, like, I don't know, like maybe your app's more complicated than a flat table with 10,000 elements. I don't know. So, I mean, there's a world this could be a thing, but I just wanted to kind of like talk about like the nature of these kind of benchmarks. And actually I talk about them. The snapshot benchmarks, which is a diffing benchmark, which favors VDOM. And then in my article, if I go down here, the last one I called the to-dos benchmark. JS framework benchmarks is the to-dos benchmark. It's basically just use the large table. Almost all JavaScript frameworks are benchmarks for UI frameworks fall into these three categories. But yeah, we're focusing on animation today. So the other example is this one, Sierpinski triangle. And this was a very misunderstood benchmark. I tried collecting all of them I could for all the different frameworks here. And if you actually go into like almost all of these frameworks, they're like, look how great my thing is. And they did stuff like this, increase the number of dots. Oh, okay, I increased it too far, sorry. But like almost everyone missed the point of this demo when it came out. Sorry, I need to get out of here. I killed the imbo one. Okay, I'll double it. I'll decrease. Okay, I'll double it. And then they go in and they do slowdowns. And like obviously this is updating fine with like these number dots. The problem is these demos didn't do one thing that reacted in the demo, which is really important. See, increasing the dots, all that's doing is increasing the brown, essentially. As you can tell, any framework can do a lot of dots here. Let's do here 4,000. It's starting to sluggish a little bit, but you look at the updates are keeping up with me. Yeah. So if I go back to 1,000, everyone can do 1,000 in their sleep, right? Even under probably significant slowdown. I'm just using IMBA here as an example, but if I went to performance here and then I was like, okay, let's do something like throttling. Let's do like 6x. 6x, not a problem. Can we do 20x? Okay, 20x is starting to be a problem, which makes sense because 20,000 was too much. But, you know, because what my point is, like, yeah, it's not having a problem with 6x slowdown. Like, this is not, you know, this is not testing anything. Scaling up the DOM elements, not testing anything. What if we go back to the original examples without slowdown? Yeah. What stencil do? I thought the stencil was cute because the stencil version works fine at first, but they do have the slowdown, so they are doing the thing right. I think stencil was really cute because you could get an idea of how frameworks worked. Actually, this one stays smooth. Good on them. Okay, yeah, so they did a good job. Okay, never mind. Okay, so stencil did it properly. I don't know if they did originally, and maybe they've updated it. But the whole point of this demo is the original React demo looked like this. Like with old React, you guys can see a jump. It's not even animating in between. I don't know if the old React could even render the circles properly, but definitely every time the count goes up, it has an issue, right? And then the React Fiber version obviously was butter smooth, like we were seeing, right? Right? Beautiful. And I also made a Solid version for Solid 1.0. And this is actually using time slicing similar to the React version. Okay, cool. Let's look at the code for this for a bit to understand what it's actually doing. I actually remade it. Sorry, stack blitz. So let's look at this one. Oh, they're gonna make me. Okay, let's sign in. Okay. Give me a second. I feel like security's gone up everywhere recently, which is good. It just feels like I'm always getting booted out of everything. Okay, cool. I'm going to show you the code. This example is not doing what we want it to, but you could pretend that the original code is essentially this. Like this example is smooth, except when the numbers count. Smooth jump. This is kind of like what I'd expect it to do. But I'll show you the code. The original demo code was written in class components. Let's ignore this for a reason. I'll explain why this is looking like this. But this is essentially the equivalent React code so that we can understand what this demo is showcasing and why it's so cool that in our old version of the demo here with React Fiber, that we're getting this butter smooth animation, hover states are updating and whatnot. So the idea is this. The triangle demo has basically two states in it. It has an elapsed timer that updates it's using request animation time. It's basically the total time that's up that's happened since the app started using the timer from the request animation frame. I think. Let me see. Let me look at the update. No, it doesn't actually use the timer. It just does date now versus like the current start times. Whatever, doesn't matter. And then the second thing it has is it updates the seconds mod 10. So it goes 1, 2, 3, like every second with on an interval, it updates that 10, 1, 2, 3, 4. Sorry. Okay. So every second it's 8, 9, 10. And the trick to this app is that the elapsed time here is only being used to calculate the scale, which is just like some math here. And the scale is being used in the root component to do a JS or to do a style transform on the DOM. So the scale never goes down to the children. It's literally just to the whole animation you're seeing where they're shrinking in and moving here is actually controlled by CSS, which is the way it should be, arguably, right? But the children get the seconds, and each triangle down to a certain thing where we finally render the dots basically passes those children through to its three children. So triangle begets triangle begets triangle. The big gotcha here, and the thing that a bunch of them skipped, is in the middle of each triangle component, we have a synchronous blocking loop, which is heavy, right? It's you might be like, okay, performance now 0.8. So like, how much is that? Like 0.8. Like that's not much, right? But if you add it for every single triangle, and you have to think about it, you hit the component, render the children, each one, it just keeps on adding to it because you start rendering and you wait, then you get to the next round, then you wait. It's cascading. It's like a waterfall. This is a beautiful example of making the blue large because they actually get through the React component tree is kind of expensive here, right? It's like boom, each one. Now I'm going to remove this transition for a second. Start transition just for the sake of, okay, let's see if I can do this. Yeah, okay. And keep in mind, I'm in dev mode. You get better performance outside dev mode, but everything I'm doing here today is going to be in dev mode, so it doesn't really make a huge difference. The point is, you see it animates, and then every time the number happens, it freezes. And the reason for this is, see, we memoize the component. This is the key to this whole thing. We memoize the triangle, so every time the scale updates, like the elapsed time updates, we don't have to re-render any of the React tree. It just stops at the top. So the animations can happen without re-rendering the tree. But every time the seconds go, it has to get all the way down to the dots. And every piece in the middle is this expensive thing. I mean, as long as it's not too long, I mean, but this is clever because if I remove this, it's easy, right? Nothing happened. Like this is easy, right? If I add this back in, we start having some fun. Now, here's why the fun is a problem. Let's see if you can see it on stream. Do you see how the hover state is not keeping up with me? When it freezes up, the hover state, the yellow, stays away from where my mouse is. Can you see that on the stream? You can see that, right? Like when I move the mouse, like the old hover state, when it freezes up, happens. Yeah, okay. So this is not responsive. This kind of sucks. Well, the hover state is happening from JS. It's the animations are CSS, but the hover state is happening because we go on mouse enter, on mouse exit, we have events, and we go set hover true, use state, and then that updates whether we apply, where's the hover up here? There's two places. Background, we change the background color from blue to yellow, and we also add these stars around the children. But you can see the problem. I mean, you could do hover with CSS, but the point of this is to show that the whole thing lags, even though the user input should take priority, like whether this was typing or clicking. Right? So you start understanding this demo a bit better because it's dirt simple to render 1,000 circles, but it's not dirt simple to render 1,000 circles that are artificially long. Now, if we use what we've learned about React's transitions and time slicing, then this example gets a little bit more interesting, right? Like, you know how to solve it, right? What's beautiful is that the blue outweighs the brown in this example. So we have a very different scenario. Right. So let me continue. We can almost keep these exact same things, like examples, except like just scale down the brown part. Like if I move, second, let's zoom out and move over here. Instead of click, this is hover, but you get that it's the same. You get that it's like the same thing, right? Sierpinski, right? Instead of click, it's hover, but it's but instead now I'm gonna delete the whites. I want to delete the white circles because I don't think they're actually that useful. I thought they'd help me like group the stuff, but okay. So now we're in a world where this is small, kind of like this. And again, if we have a couple clicks happen, you know, it doesn't matter if it's on blue or on brown or whatever. We take our gotta go a little further, sorry. We take our thing. This is so long it was off the end. The naive approach is still going to end up stacking it like this, but yeah, I'm just going to skip this example. I don't care about this. Keep on going. We're just going to focus in on the last two scenarios. Right. Hover happens during, with or without time slicing. All right. So we only need 2 of these. Okay. Let's start with, you know what, actually, we don't even need naive because like this is actually the same example here, right? See how the first two are the same. So what does time slicing allow for us to do here? That's where it's interesting, because we can now interrupt the blue, skip the brown, and do this. And because most of the work is happening during the blue, this is actually a much more significant win. Especially if like we get multiple of these events, you know, stacking, because I mean, if you take my original example again, let's pretend it interrupts it again. Is that another one of these? trying to get as close as I can to like the original demo up here. You know, I'm gonna move this one back here. This compared to this is actually a significant difference, right? In fact, this is why I've always liked this demo. The trickiest thing about all these demos is they all involve propagating fully through a tree, and it always starts at the beginning. So you always have to do all the work when you resume from interruption. There's no way to continue because you've lost that state. In real world applications, there's probably some state that you didn't have to resume. But your question is, how is this slice interruption? Well, back to our old queue, React queues up work. Yeah, I guess I haven't talked about framework timelines yet. You know what? This is a good point. Let's take a little sidebar here because I talked about the DOM, like the browser scheduler, but I didn't talk about the framework scheduler. I've talked about this in previous streams a little bit. There's actually probably a drawing in here where I talk about this. Is it way up here? What's this? Zoom in onto this. No. Move way up over here. This is going to be useful here a little bit, but generally speaking, there's like 4 phases that happen when you do an update, right? So like first there's the browser event, like click whatever, and then you do the thing, and then you run your event handler, and during your event handler you write some state, right? I don't know why it's weird. I don't know why the React one is slightly out of line with the other ones, or why this one is. But my point is, you write your state in the event handler. Then this usually schedules some kind of work to happen. And in the case of React, it schedules your React components to re-render, right? Which is when it commits the new values. Basically, when it goes, okay, state was 1, now it's 2. And it also, during this, runs all your components. And then at the end of this, this isn't actually correct. I said this is scheduled, but to be fair, it's more like this just continues on from this. It's usually not scheduled. I mean, it's part of the same scheduling. Continued. You can, yeah, it's not scheduled. This is more like continuation of the scheduling for these two. What I was trying to get here is that during this pure computation, now when the state gets committed is arguable. Maybe that happens on like the other side, but inside the graph, you see the next value and you're running it. And then at the end of running all the components and you figured out your VDOM or whatever, you then apply that to the real DOM. But this process of running the components, classically, if you look at like a tree, you're like, oh, well, I mean, let's look at open another playground. Like you see these JSX elements, right? Kind of conceptually, and you see this as a function. So you call a function and then you run all this stuff. But the reality of it is, the thing is, JSX, I'm going to remove a bunch of extra stuff here and just focus on our JSX call here. Shut up, TypeScript. Okay. I mean, in React, it essentially gets turned into like these functions. I call it H functions. It's like, let's create a select element, and then it has some props, and those props are essentially what I'm seeing here. So X. whatever. And then it also has children, and those children are going to be like, I'm going to put an option element in here. Let's make it an array. And then some of them can take n arguments, but I'm just going to make an array to try and hopefully clear it up. And then there's a component in here. Now, this is solid component 4, but it doesn't actually matter. The hcall could also be for a component. So instead of a string, it's a function. And again, we pass our props through. And in this case, the children, so it's just each, and then the children is a function. Okay. Actually, let's keep on going. Children is a function, and then the children also have an h function in it, which is an option, which has props, value. Yeah, it's funny. I got the one problem. I'll fix it in a second. Value equals this, and then also has children color 0. Missing curly braces, and then these are not equal signs anymore, they're colons, and instead of being delimited, they're just the value. I screwed something up. I knew it wasn't going to be that easy. Or I didn't close the array. No, here. Format. Okay. It doesn't matter a ton. Just options. Child 1, child 2. Okay. Yeah. Oh, yeah. Silly me. No, that closes that. And then that closes that. Then that should have worked. Whatever. Hopefully you're familiar with this. Sorry, just catching up with chat. What do I think of View Vapor? I love it. Obviously, it's basically SolidJS. I need a comma before on change. Oh, yes. Thank you, chat. It's always one thing. Okay. Yeah, thank you. Okay, so my point is, though, is that if you look at this, even these functions execute inside out, right? Like this h function can't call until this h until it gets its array, till this eighth function, the eighth function. And we know that in React, components don't render inside out, they render top down, like the actual component body. So what's important to understand is it's not just like the single pass. Component generates like some VDOM markup here. This will like produce a bunch of objects. But then the for doesn't run as part of this app running. The for makes the decision to run afterwards. So you get this output back, and then you go, okay, now I run for. It's not like if for was like whatever down here, and you put a console log, hi, and you also had a like this didn't return. You had a console log app. Okay. And then we went const VDOM equals whatever, and then we return our VDOM. I don't know if a lot of people spend time to think about this, but my point is app logs before hi. Right? Like the function produces a bunch of artifacts, then decides what children to render when, which means there's an opportunity here that React is actually like, I'm not going to explain how Fiber works right now. I don't even probably know in any kind of detail, but my point is that there is a time period when it goes between it running this component and it running this component where it can go, should we continue? It's like a queue. Like it can produce this, go, okay, I'm going to need to render for coming up, and can queue it and go, okay, I'm actually not going to continue. You know, like it's not just like it calls one function and the whole thing just runs, which is actually how Solid works. Which is the way we solve it is how do the children not run before the parents? Well, we wrap everything in functions more or less. So, and because we wrap the things in functions, kind of similar idea. It's more granular. It's not like the whole block, but it means that like we don't immediately, we'll immediately run for. Ironically, we'll actually immediately call for in Solid. Like we'll call it's just a function. So we'll run down your whole tree, but when it comes to the elements, when we'll create the elements. Yeah, actually, you know what? Where am I going with this? We actually do just kind of create everything. The thing is, RJSX just doesn't nest like this. Like if it did, where it does nest, we have function calls. So like, but generally speaking, when you call app in Solid, the whole tree just runs in one go. Yeah. So like basically there's a list of components where in Solid it's the reactive system that does that scheduling to a certain degree. But this is important to kind of understand. There is a natural place to split, and it is useful on creation, right? On React, their updates and create are the same process, right? Whereas in like a fine-grained system, the updates are different. They only need to rerun the parts that change, and all that work is scheduled into separate places in the queue. Whereas, generally speaking, the only part of Solid renders everything initially synchronously. So there are consequences of that, but it is important to understand, because when you ask how things can be interrupted, it's because React does multiple, it's like a multi-pass almost, like it renders, analyzes what it renders, then renders some more, and there's a natural place for it to break up. Outside my own render, I thought about lazy version, but I can't find any usage on the wrapping anything in calls or generating. I mean, that's what you have to do. I mean, the thing is, we don't actually have to wrap that much stuff. We only care about the stuff we wrap in terms of what will update independently. It just kind of works out that way. Context is an example where, yeah, I mean, the thing is, because our siblings are basically parallelized, and then like a for loop, because this in solid, this will run, and then this will run. Like this one's already wrapped in a function, it's fine, and then this will run. But because instead of us making it hierarchical where you can't create select until you create this, Solid's output is more like, well, I will refresh this and hide it. We'll lose what I just wrote. But Solid's output, if you look at it, the same stuff, is it creates the elements up front at the top, or at least the first element. So it creates the select. This is it creating the select. It's actually creates it from a template here. It's the select option, and then another template for the option. But it actually creates the element here. So it creates it here, and then it's not nested. So it creates the element first, and then what it nests are like the inserts. So then it creates the component here, also not nested. So it flattens out the set of instructions. The only thing that's actually nested here is the children, where we do the for loop. But and even the setting the reactive props is also not nested. So Solid has this funny way of unnesting everything, flattening everything, which means that most things actually just execute in the order you see them, because we basically flatten the templates. So anyway, okay. So we like the things that need to be wrapped in functions are a lot less than you think. It's because we don't generate hyperscript. Okay. So yeah, I hope that answers the question of how they can interrupt. But it's important to understand, like, this blue part can be interrupted. Which is interesting. To be fair, in Solid 1.0, I showed you that demo working. We interrupted the green part. Right? So getting back to my stack blitz, you might be going, well, if the original React demo acted so awesome, why is this one like this? Well, first of all, it's not just naked using set state, where like you see how the delay happens. The solution to this problem is transitions, right? So the original version had batched updates, but it's basically the equivalent of this start transition thing. Now, what happens when I change this to start transition? Well, it's still having an issue, and we'll talk about this in a minute. But if you look now, the hover state, oh, I guess it still gets locked up. What's interesting is if I leave it alone, it smoothly animates until it hits a number. So it's like smooth number update, smooth number update, smooth number update. But as soon as I start hovering it, it actually stays smoother. It skips some numbers, but it actually stays smoother. But it's not as smooth as the animation. And the reason is, the biggest difference between the original demo and what happens here is, in the original demo, they decided that transitions were lower priority. So when you say this is in a transition, the set seconds is always interrupted by the elapsed time, essentially. Whenever the animation changes, it always interrupts, which meant it was always smooth. And what's happening here is when I hover, the hover is like, I'm beating all of you. I am super high priority. So it will try and render at that point in time. If you notice this, when I'm sitting there over it, the number freezes for a very long time. Like, it's still showing 2. Even, okay, now it goes to 7. But if I stay on here, okay, but it starves the transition for a while, and then eventually it will jump like 5 numbers because it'll go, you've been starving too long, I'm gonna run you. That's kind of how they work. And when it goes, I'm gonna run you, that's when the whole thing freezes up again. But see, if I leave it to its own devices and I'm not hovering, it's not going to miss a single number because it's not getting interrupted, and it's just the pure bulk. The only time it's getting interrupted is when the new second comes in. So they basically made a decision here where they decided that because we don't want transitions to starve, we are going to we're going to not make transitions a lower priority. They're the same as the main thread priority. The only thing that's higher priority is when the user clicks. And at that point, the transitions do starve. You see the numbers get frozen, but until a certain point when they finally force themselves in. So that's why this demo is no longer good anymore, because the priority isn't being set in the same way. In the old one, they said that transitions were always lower priority. Does that make any sense? I mean, we can go back to Scheduler to explain this, but essentially, if we look at the our drawing here, let's go back to where I was rendering these things down here. Here, zoom back in here. What I'm saying here is the way this interruption works, the framework chooses whether it interrupts or not. If it doesn't interrupt, you end up with this. So essentially, what's happening currently in this demo is that there's basically two types of workflows. There's one that has a short blue workflow that happens all the time, and one that has a long blue workflow, but it happens once a second. And every time they hit each other, they interrupt. So like, or they don't interrupt because they're the same, they're the same priority. So essentially the long blue workflow is pushing out the shorter blue workflow. And that is what you're seeing here when I'm not hovering. It's short, long, short, long, short, long, you know. Whereas in the original demo here, they decided that the short always interrupted the long. Okay. So the tricky part here is I'm hoping from this, like, you can see the value of transitions a bit. Like, the problem is most workflows that people are used to look like this, where there's a lot of brown, which means the transitions aren't doing anything. This one shows that if the blue was hypothetically large enough, you know, and again, snide remarks people make towards React, like, oh, it's because your framework is so slow, that's why the blue is long. But like, we can at least artificially produce the same thing. You can conceptualize that there could be a place where the blue is longer than the brown and that you could benefit from it. The tricky part is well, what we're seeing here is like, you got to put the control back in the developer's hand. We can force flushing, right? Like what we're doing with the hover, but then what we're going to end up with is, this is how the stencil demo used to work, by the way. It would look kind of like mini choppy instead of big choppy. Like, it looks similar to like when I'm hovering over this. The problem is, as a developer, how do I make this demo nicer, right? And the answer is, it's like, it's not really obvious, because before, when we said transitions were lower priority, that's easier. In React, if you call flush sync yourself, you set higher priority so you can interrupt stuff, which makes sense. But you know, someone's going to starve. If everything's high priority or higher priority, then the thing that's not higher priority is going to starve. Like the transitions here, you know, when I get stuck on the number. In the old demo, if I put the slowdown slow enough, without even hovering, that number is never going to change. I don't know if you can see, but it's stuck at 10. Like, it's not even hovering that needs to cause it. This number will never leave 10. This was kind of what they wanted to solve. because transitions just starve for all eternity out here. I mean, oh, interesting. Part of the triangle became a 1. I think we snuck something in somehow. Is there a way to get smooth behavior in the current React? Seems like a valid use case. Well, I don't know if they have hidden APIs to deprioritize. They have this is higher priority, but I don't know if they have a deprioritized way. I'm not sure. Ricky was like, oh, thinking of like using a different solution. Like when I talked to Ricky about this in the thread, he was like, oh, it's funny. Some of these are 4 and 8. He was basically like, it kind of sounded like this is just not a good demo for time slicing anymore, right? So it's kind of like, you're kind of like, but how do you do this then, right? And I was kind of like really struggling with this because the reason I built the React Fiber example is because this has been, the other benchmark sucks. We already talked about it. It's completely useless. But this benchmark at least showed transition time slicing in action. So I was like, is there a way that, like I wanted to look at what React's doing now and see, because I've been debating whether I want to do time slicing. Now, one of the cool things about R3, the new React system we've been working on, being heap-based is, unlike current solid, like the way time slicing works is really naive. Like we have a queue, and when new work comes in, we just keep on queuing the stuff on the end of the queue. And if it processes it, it marks the node as being processed. So if no other updates happen and you hit it again in the queue, it just skips over it. But if an update happens and you hit it again in the queue, well then, so you can kind of like pause the queue and then continue the queue. And then, eventually when the queue's empty, then you can put the thing on the page. That was basically how I designed time slicing, because our pure computations, like our memos and whatnot, essentially all just get queued up in current solid. It's eager. Every time you do a reactive change, it adds it to a list. Whereas in the new system, it's heap-based. So instead of queuing everything on the end, it checks, it goes, am I already in the heap? And if it isn't, it doesn't add it again. And then it removes itself when it does. And whenever it gets inserted, it doesn't insert it at the end. It inserts it in the right order, like at the right height in the queue. That's why we don't need to add it again. The reason I kept on adding at the end is because in the old version is because even if you said like, hey, I've already been processed or whatnot, the problem is if you've already gone like past where it is or not past where it is, you'd hit a place where stuff could get skipped. So the easiest way of like checking instead of going like, am I in the queue? And am I going to execute in the right order? It's really important. Like you don't want you have to make sure that stuff always executes before the other thing. Because of the graph propagation, it was kind of a mess, but it just kind of worked. Whereas in the new system, if we don't get to processing something, we can just start the heap at the top, and just as long as you run the things higher before the things that are lower in the heap, you'll order them in the right order, and you won't have to keep on expanding the heap. And because of the reactivity, we get to reuse the nodes. Like it's almost like the perfect data structure for time slicing. Yeah, I mean, possibly, but the tricky part is, well, this is what I was talking to Ricky about on the discussion here, is because I was like, if the other demo is garbage, what's a good time slicing demo? Because this was the only good one, and if this one's not good, we have no time slicing demo anymore. And he pointed me at a bunch of like previous talks, and one of the challenges there, obviously, sorry, I want to Discord. I just keep on notifications. It's nothing solid start stuff. Those talks, the things, they were great IO demos. They're great at showing like page navigations, but the time slicing demos actually all suffer from the problem we have. We actually don't have a good time slicing demo. And again, pessimists could argue, well, that's because time slicing is useless. It's not. Ricky actually pointed out a few places where like bursts could be valuable. Let me see if I can find it on my profile. I can dig into this because yeah, yeah, I was trying to figure out why my demo wasn't good, right? Someone wrote an article, and I'm actually gonna link this article here because they basically were like, their solution was like, just don't use time slicing this way. They found the same thing I did, and they actually found this earlier in the year. I didn't even realize this. But their conclusion was like, we should just move all the animation out of JavaScript, and it's like that's great. But they saw the exact same thing I'm talking about, where this actually shows it better than I was doing, where like the stream I don't think actually shows it. Read this article if you really want to understand why this, like, not why, but how it doesn't work anymore. If you want to understand, like, this is how you fix the demo in React, I guess is the thing. But you fix it by just not using JavaScript. Like, you know what I mean? Like, by not using the framework is how you fix it. Is chat still live? I'm getting told I have internet connection problems by StreamYard right now. It's fixed by smoothing CS. Like, yeah, I know, but I mean that's kind of like basically just saying it's the wrong example. See, yeah. So Ricky talked about this. Yeah, that's roughly correct. There are multiple differences. First, we don't use wrap for scheduling anymore. See. So the timing wrap updates and timer updates of the demo are different. Second, we don't interrupt default updates for transitions anymore to prevent starting the transition updates. So the update scheduled in the wrap will not interrupt the rendering of the transition. You can see that as an update blocked in the performance trait, right? Which is cool. Their performance trait thing is awesome. User events like hover do interrupt transitions, which is why hover is smooth. We also flush all scheduled sync updates at the time, which is why the animation is less jittery as you hover. It kind of goes like a slow jitter. You can see it's interrupted by render, yes. You can kind of fix this by wrapping set elapsed in flush sync so the animation updates and run the transition, but then you'll see a different kind of issue where the numbers don't update, then a bunch of frame drops after a few seconds, and yeah, it's like as if you were hovering the whole time, which is also not really what you want. Because flushing is starving the transition by interrupting it, and then it finally overruns a timer and stuff. Basically, like, no one wins in these scenarios, and this has been kind of the hardest part about time slicing, because it's like people want a demo where you're like win, and the answer is always like, yeah, this is like, this sucks less. Time slicing, we suck less, you know? And it's like, because it's like dealing with a reality that some software sucks, and it's like, the problem is like, is it easier to fix the problem or let it continue to suck for a bit longer? Is basically what we have here. There are plans on improving this in the future, though. For example, if we add reusability, then we can interrupt. When we interrupt, we don't need to throw out the whole screen start over, allowing to complete before expiring. Now, again, I don't think these demos will actually benefit from reusability as much. They might a little bit, but like, it's because they're stupid. Like, literally every node is touched, like, as part of the update. But conceptually, I agree, because we have reusability essentially in our transitions in Solid to a minor degree, because we reuse the reactive graph and the state. So it's essentially, we have this. So yeah, I mean, it's one of the reasons, again, why we edge out slight performance things. But demos like this aren't really showcasing it, because like every node gets rehit. Like, you start over from the beginning. You don't get to save any of the work. We can also yield less often. Yeah, I mean, fair enough. But you understand, he's not making excuses. It's just literally, it's a crap situation. There's no good solution for it generally. Overall, this kind of shows how much we de-emphasize the CPU case, which has been kind of my hunch all along. We're coordinating for async now animation, not the speed of our slow rendering. In this case, there are better ways to drive smooth animations. Agreed. I was going to say it must be the interruption that is expensive, because updating elapsed almost immediately memos out. It has nothing to do with the count. It isn't that deep of an update. Thank you for answering my question. So I guess we need a new time slicing demo. I wonder if one, like the UI mirrored where your mouse position would be the right sort of thing, or expensive to happen. But the more I think about it, that's not even the case. Like, that's like him calling flush sync inside the timer. Like, as long as you're not willing to let something starve, you're going to have crappy UI experience. but it's hard to make that decision from a generic standpoint. Oh man, you gotta put the ball over your UIs to make it real, or it was like that time period where like Dan Abramoff's radar started showing up on like every demo. Animation red herring, you'd have the same issue with imprinted counter or live data. Yeah. I mean, we saw it in the bad example. Yeah. Well, it's the problem is the blue has to be big enough, which I'm going to get to this. So I guess we need time slicing demo. All the triangle demo did was leave me to that. I'll do that. Just to clarify for readers, it's not the interruption itself, like the overhead of interrupting, but the need to restart the entire render once you start back from the transition. Yeah, I wasn't clear about that. I do think we have better time slicing now as part of Dan's two-part. Yeah, and he points at the IO part, which is great. This is the tab demo. That's what sold me on an Andrew's talk, the one with hooks, right? And yeah, Dan's demo is what sold me. People were like, if you go back to 2020, I wrote a post on X that was like, or Twitter at the time, and I said, I'm noticing this negative sentiment around React, and I'm like, I don't think it's called for at this, at the point I was saying that, because like the React's innovating really cool stuff on this concurrent stuff, and people are just like wearing a badge around frameworks like we don't have concurrent rendering, and transitions were a great feature. I just I might not agree on the time slicing part being important, but like people were like wearing it as a badge that they didn't have this like async consistency, and it's like, you guys are crazy, right? Like React is working on something important here. And it's because right from that first demo, I was sold. With the tabs, it was like a movies app. It's time sparsely with the CPU. Yeah, time slicing matters for other features like suspense. If you're mounting a new route that is suspended on data, and after the data comes back, but before the data paints, the user switches routes, the UI should stop doing whatever it's doing to handle the event. Or on hydration, if the user interacts while hydrating. Okay, so these are two things. I trust you all have done the research. It just feels to me in both of those cases, the actual latency is a limiting factor, right? Like if you're fetching data, it's actually like the freaking 200 milliseconds you're waiting for the data, is probably longer, maybe, than like the render. Like if you click to the next route and then click back again or click a different route, you're perfectly fine until the exact moment it's rendering that route. So like, again, is it, how much of it is, where's my scala draw? How much of it is like this sort of problem where instead of this being an event, there's a very long async thing, like a different thing out here. And then there's this, and there's literally just this sliver of a blue that you can perfectly hit it where you can actually make a benefit, is sort of what I was wondering. Like moment when data comes back, the person could have interacted with the page without issue until that moment. And the time between the page being visible and JS load is probably significantly greater than the hydration cost. For the former, there's that burst, I suppose, that could be curbed. And for the latter, you probably need to record the event and replay anyway, pre-hydration for reasons above. The reason I was looking at demos was trying to determine how much I wanted to invest here in time slicing. If I do like the direction you have taken to time slicing now is easier to replicate. You don't care if it is a transition or not. But if it was sourced from a high priority event, which means on versus off screen isn't like a consideration, right? Yeah, I mean, from the user perspective, since async is in the background, they will only see the input or animation jitter from mounting the new page in the background. For new routes, it's not uncommon for those just to take a while to render and commit the entire page. Another case is scrolling. If you select a filter in a list or get a WebSocket message in the background update, you don't want to scroll to feel janky. So like these are hard to test because you're not going to see these on animation benchmarks. These are bursts. These are things that happen where everything just happens to happen at the wrong exact time and you get that small glitch. And funny thing is people are kind of used to this, especially around affordances around loading, but they're hoping to you see, like these are actual use cases where you can understand where you have like a sudden burst of rendering or something. And the trickiest part though, as I said, is it has to be a blue burst. It can't be a brown burst. It has to be a blue burst. No, the benefit of transitions is not this stuff. Time slicing and stuff is not it. The benefit of transitions is being able to load the next page while showing the current page. It's being able to have the page be live. This has nothing to do with time slicing. It's being able to, you know, be updating something, have work be going on in the background while keeping the current state of the page consistent. You can do that without time slicing. You don't need to split up the execution, you know, and interrupt it and stuff to do that. You just need to hold the committing of values and updates to the UI until a point. Yeah. So I'm actually going to show you. But okay. Maybe it'll help people understand a little bit better by actually showing the solid version of these demos, because I pulled this out. Okay, this is the original demo, and if you look at the source code for the original demo, we calculate the scale, and then the more important thing is you notice is where the work happens. We have create memo, and we have create memo for our artificially long delay. And the reason I want to point this out is solid components render only once, right? So if I just took the React example that we've been looking at here and wrote this, you know, and translated it to Solid, and some people who didn't add the slowdown were reactive libraries where they're like, look, we added the slowdown, and they literally stuck in the component body. I'm sorry, this component is never running again in a fine-grained thing. So this slowdown is never happening again. That's not testing what it's supposed to test. You have to understand that what the slowdown is doing, which is basically, since these are all static props, the slowdown is basically it's a calculation based on the children. That's the way you should view it. When the second updates, each component along the path has to calculate something really expensive based on that second, and it passes that expensive calculation down to its child, which has to calculate something expensive off that expensive calculation that cancels something expensive off that. So the way you model that in Solid, sorry, not this. The way you model that in Solid is you create a memo that basically takes a while and then returns seconds back through. And then you pass that as the child to the triangle, and then it gets it again, and then also calculates it. And so you just do a bunch of memos all the way down. And if you naively take this example and do that, it's going to look identical to the version of this that doesn't have transitions. If you just literally just took this version, right? So to have that same, like, I'm not going to bother, but it's identical to this. In fact, I think Ricky tried to add it in, but he actually added a second delay. I already had the delay in there. Let's just do this for fun. The problem is, if I do it for fun, I'm going to show the solution off that I don't want to show yet. So let me grab this. I'm going to fork it, and then I'm going to make it. Yeah, let's just do this, and then I'm going to remove all of this stuff. Sorry, give me 2 seconds. I know it's not much of a reveal, but I just humor me here. Okay, cool. I've remade the demo here. Sorry, I grabbed the wrong window. Give me a second. There we go. Okay. So here is the updated, it's using the Solid 2.0, but this is the updated version of that demo, right? So look, it's just like React. It skips on the numbers, it's smooth in between, and then when we hover on it, we can get locked out of the hover state. See, it gets delayed. It's a little bit, performing a little faster than the React version, but like not acceptably so, minutely so. Anyways, but you get the idea. And how did we do this? Well, our slow children, we created a memo, passed it through, and this behavior is identical to the React version without a transition. And you're probably like, oh, what if I add a transition to Solid? Will that help us? No, because there's nothing async here. We don't have time slicing, right, in this version, right? So this is our baseline. You just have a memo. But I want to show is that conceptually, because the component runs once, this is actually a really good show because you understand, like, it's this that's expensive. You don't, when you're writing an app in Solid, because the components don't render and you notice something that's slow in updating, more than likely it's going to be some point in your reactivity where you're doing like a calculation or something stupid, or like this is, you know, it's going to be wrapped in a memo somewhere, or it's going to be wrapped in a function call or something. Like essentially, it's not going to be part of the component body. It's going to be a very specific isolated chunk, right? So, okay, I've made this now, but it's important to understand the difference here so you can understand, like, yeah. Doesn't matter. I'm going to delete this after anyways. But yeah, okay. So now I have this silly example that's not very useful. But I showed you that the old Solid example. Hey, Luca, how's it going? You managed to open the door to my office.
This time you actually did.
My point is, I showed you this demo and it was butter smooth. How did that work? Yeah, well, we graphed the whole graph, so we could definitely measure the execution time of, I suppose, if we wanted to, of specific computations. I mean, that instrumentation might be expensive, but anyway, how did we do this? Well, we called enable scheduling, which turns on time slicing in Solid 1.0, right? So the funny thing about this is time slicing is awkward because if you interrupt the memo on its initial execution, it hasn't processed yet and it's undefined. Sure, we don't end up running it in the effects, but there's some weird oddities here. Lucas slicing your time for a moment there, yeah. You know, party Friday. It's the last day of work for a lot of people. Go party. I guess the whole point of React Firm is that it shouldn't be interrupted at all costs. I mean, you need the graph to be consistent and you know, but it only matters at the end if you can see it. If you keep, like, the cool thing about transition, there's two things here I showed you actually. The second thing that happens is we call start transition. This means we're not committing the values. So if something outside reads, it's consistent. It's only inside the transition, which hasn't committed any effects. So you're kind of safe, except for, like, I occasionally, I never debugged this enough with the time slicing that I'd hit undefines and it was kind of like annoying, and then I'd like fix it to do a null check and then everything would work. But I never felt comfortable taking this out of experimental. But like I could remake any React demo I wanted to and it worked because I did the same thing. I said transitions are what make it lower priority. Obviously React has walked back from that. But the demo otherwise is the same, right? We don't have the memo. Instead of wrapping a memo around the component, our components run once, and then it's our expensive memo that reruns. Okay, so then the question is, I was looking at this and I was like, can't we just solve this without time slicing? I mean, we talked about the JavaScript scheduler at the beginning. I mean, there's similarities between all of them, like the way the browser schedules paint and the way we schedule our effects to run are kind of like, you know, but yeah, I mean, the problem is like what I'm going to say is this is not like database transaction scheduling. Like a framework scheduling is more similar to a browser event loop than it I would say than it is to like a database, which is transactional and stuff. Like there's but like a browser, I imagine there like at least the UI part, or sort of like a OS, like the UI part, there is a need to show stuff on the screen and not lock up. I don't know. That's a good question. We're also in JavaScript environment, so we're single threaded. The overhead of multi-threading was something that React looked into, and they decided it was not like there's a framework that does multi-threading. I can't remember what it's called, but yeah, okay. So how can we solve this? Um, solve this, and the first thought is like, what if we made this async, right? So I'm actually let's do this. Let's make this async. Create effect. The best way to make things async, right? As I like hovering over create async. No, let's make this async. So how would we make this async? Well, let's go const. Let's make slow children equal or let's just call slow set slow equals create effect. There's a reason that I'm doing it this way. Props dot children. The reason that I'm doing it this way, yeah, Neo MJ, yes, that's it. Yeah, Neo MJS. I was like saying NeoVim, and I'm like, that's not it. Well, the reason that I'm doing it, sorry, props. Let's so let's see if we could offload this. Right. So sorry, this is create signal. That's gonna default to again. You right away you were like, well, what's the original value? Um, let's just. I mean, you start hitting the problem immediately there because you realize you have to have a default value. I guess it could be 0 because all the clones render at the beginning. Let's just make it 0. Okay. And then let's make it so that let's set timeout inside our effect, right? And let's make it so that we take our expensive work and then let's call set slow equals our value, and then sorry, slow children, and does this work? Oh, nice. Does it work? Oh, sweet, it works. Okay. Not quite. You guys won't be able to see this. I mean, this basically works, but there's a problem with this. I can see it on my computer, but you're probably not going to be able to see it. Let's increase this briefly to something bigger. Maybe you can see it now. Let's do something even insaner. 6. Okay, yeah. I mean, you're seeing it super slow down, but and actually we should do one other thing here. We should go const t equals timeout, and we should clean up our timeout, right? We should go what was it? Clear, is it clear timeout? Clear timeout t. Okay, let's do this because we're queuing too many timeouts too. 6 is absurd, but I'm hoping you can see it. It's fanning out through the app. It starts up near the top and then 5, 5, 5, 5, 5, 5. Like it's hard because I like this example is probably not as zoomed in as it needs to be. I mean, maybe if I can open in a new tab and then like really zoom in. Yeah, okay. Do you see it fanning out? Like the numbers aren't all updating at the same time. This is why React didn't want to do this. Because you're if this is part of your data grid, you're presenting an inconsistent UI. I mean, increase the added number enough and it'll lock up. I mean, that will happen in every scenario. It will happen even in that old original React Fiber thing. Right? I already showed it when I just went to slow down times 20 when I was in the old Fiber demo, that even the old React does. This number is not, there's no permanent solve. Something starves. So each render effect and run immediately is this case. Well, yes, exactly. Yes. So this, yeah, 6 is insane. Let's move it back down to our 0.8. A lot of people probably would be okay with this, but I can actually see the ripple effect. I don't like this because it's inconsistent. A UI framework shouldn't be inconsistent. And for the longest time, I was kind of acknowledging this in my head, and especially the ways, you know, stuff works in Solid 1.0. I got it. I was like, you guys, like, yeah, sure, you can always opt out. You can always go async in a granular way. You know, like this was super easy. But this is not a consistent API. What if, like, clicking on the button did something based on the current number, and then like, I don't know. Personally, I thought render effects are deferred until the graph is settled. Well, the graph is settled. The graph is settled because it doesn't know that you're going to call set slow, right? It doesn't know that. When you call, like, I could do this in React too, right? We don't need to use a transition. I can just call use state. I think it'd be more expensive because the re-render in React, but like, yeah, we use set timeout, yeah, to call set slow, right? And we can get fancy here. We can like go like, ooh, let's do request idle callback, and then go clear. Is there clear idle callback? Cancel idle callback. There we go. Ooh, it's even lazier now. So it's like updating async and nothing is waiting for it. Yeah, exactly. And this is the state of every framework and everyone for years and years and years and years and years. This is the state of things. Right? Okay. So something occurred to me a couple weeks ago when I was like looking at this, because I knew about this create effect problem, right? And I knew about the time slicing, but I was like, why create a crazy async graph if we couldn't just? I had a hunch. I was like, right, like I had a hunch, and I was like, what if we're, I'm hoping my post now, think, what if we didn't time slicing, we instead went async? So I'm going to show the example again in Solid 2.0. Again, there's no transition or anything because the transitions are implicit. But what if instead of calling useEffect, we just called createAsync, which is our async part of the graph, and then did our same RequestAutoCallback. I put it in a promise so that it would know when it was done. But now it resolves the promise using RequestAutoCallback with the cleanup or whatever into createAsync. If we did this, obviously it works like our other example still, but if we did something stupid, like make it 5, maybe 5 is too long because it's starving. Yeah, I got the tricky part about async starving because I put it inside a I want to find something that's suitable here. The trickiest part is if okay, cool, this will work. I don't have hot model reloading, unfortunately, in this example. But what you're going to see here is it's not flickering down. All the numbers are actually updating at the same time. And the reason they're updating at the same time is because the graph, it's not effect calling set state, it's create async, which means the graph is aware of itself. It means that the children and the parents don't update independently until the whole graph has and because Solid 2.0 has implicit transitions, which we'll get to in a minute here, that or at least the newest demo that I was talking about in my last stream, everything's automatically under a transition, which means it'll automatically paint hold like it is. It does mean the transition can starve, obviously, in these really stupid cases where I don't know what you're doing, but you know, until we build some kind of async starvation thing. But this has never been a problem for anything that I've actually built to date, at least. But the point is, you already identified the expensive thing. You would have had to in Solid when you're doing the create memo anyways. And now by just making async, we get the perfectly working demo here. Even, as I said, back to the original here, where the original, that's timing, I think it's chosen intentionally, where it's long enough that it's definitely more than like it delays things, but it's not more, it's not more than like it doesn't accumulate beyond. I actually had some fun making this demo. Obviously I'm canceling the idle callback, but the difference between ensuring that you get the next number, like here I'm calling set seconds with the callback version where it's calling from the previous value, so it always updates. And if I was reading and I was reading in the past instead of calling from the callback version, which is the future, if it ever kind of like got a new update before it finished, it would see the same number again, and then it wouldn't. Whereas this one always sees the next number, then it would actually like let the original finish and then it would continue on. So it's actually less jittery if you're not trying to like, if you care. See, the thing, the way this is right now is the number and the point it is in the animation are always going to, like from when you start at the beginning, are always going to be aligned. Whereas if you didn't care about that and you allow the number to, you know, get out of sync or like, you know, like let it like be a little bit behind, because like when this skips, like if I get to a point where this skips, like I put some slowdown on, it's going to skip numbers. Whereas if I had this read from the value, not the future value, then it wouldn't skip numbers. It would just take longer for the next number to show up. It's a subtle difference, but it means because you set the same number multiple times, they don't end up making extra work. I don't know if that makes sense to anyone. Can I? Yeah, actually I can. If I want to add back that flicker, all I have to do is go in here and go add the pending operator. And what pending does is it reads the latest value instead of the transition value. So if I go in here and put in the pending value, I believe I can just, if I wrap these slow children, slow children, or actually, where do I want to do it? I was playing around with this. I guess it's wrapping slow children, pending, or maybe it's actually in the dot. It's the best place to do it. Yeah, pending. This is one of the things I was actually experimenting with. If I put the pending around this that I was not showing the transition value, I do it at the dot so it doesn't impact the graph. Yeah, you can see it. It's doing the Christmas tree light out. It did it right at the beginning. See how it was blank and then it went to 0 and it waved out. So I can get the tearing behavior if I opt into it. Right. So yes, I can make it flicker like the Christmas tree still, by opting into tearing. But generally speaking, we don't want to do that, and we want to have perfectly consistent UI that's smooth. But my point is, I don't know. Do we need time slicing? Right. It's an interesting question. But I wanted to talk about it so you can understand what's wrong with these demos and what you can solve. Because at a certain point, what's cool about time slicing conceptually is the framework automatically pulls out synchronous work and makes it async, essentially. It's the way you should view it. And it doesn't necessarily deprioritize it unless something more priority comes in. But the question is like, kind of like at the beginning in the first example, I'm like, if you just put RequestAnimationFrame inside the event handler, in that one place, everything would go here. I kind of just took our expensive thing and said, hey, process this when you can. And this is the power of the async graph, because the async graph is super powerful because it doesn't have to be this. This is what if you did want to offload some work to a web worker or something. The interface that you're going to deal with there is going to be either something like a generator or it's going to be like a promise. And the create async gives you that interface where you're just like, okay, this is this work, whether it's, as I said, I made it up here. It was on the main thread and I extended it. This is still on technically the main process. It's just getting scheduled now. But if you wanted to move it on another process, well, it's the same thing, right? You just change the implementation of this and say, do this work on a web worker. Non-tearing time slicing state updates. This is the kind of entertainment I enjoy on a Friday evening. Well, hopefully some people get some value from this. But yeah, this is sort of where my thinking ended up here, because I was like, couldn't we just do it? Where's the demo? I'm going to delete this one because I don't need it anymore. This is the bad version. But yeah, I think it's very interesting to live in this world, right? Because what's cool about this example now is there's no transition, right? Did I get rid of the pending? Yeah. There's no transition, right? You just write the graph as it normally is. The only place where you need special knowledge is you're like, hey, this work is slow, I need to offload it. It reverses the mechanism. It's like, the problem with this is you have to be able to identify what's slow. But on the other hand, if you're working in a world where you don't identify what's slow, then like, eventually you're just going to drag your whole app down anyways. Okay, do you guys want to? I showed this a little in my last stream, but now that I've actually incorporated the JSX, yeah, this is the idea that I showed Tanner that got him really excited a little while ago. But let me go collections, solid 2.2 experiments. let's start with the multiply demo, which is one of Rich Harris's favorite. Simple. You have a signal. Whenever you increment it, I don't know why we pulled the increment out there. It feels like you could just inline this increment or whatever. It doesn't matter. N plus 1, and then starts 5 async requests, and each one of these async requests sets a timeout that is random timeout. So these are all each one. So if I go to 2, each one of these will calculate at a random time, and then it will show 1 times the number in the thing, right? And the is pending n is saying, is the number pending, right? It's like, is it in a still state? So so there's no transition. There is just the question of like, is this like in flight? When I click on this, you can see ... loading state. And then when it's done, they all update at all the same time. So for ... and then when it's done, it's not pending anymore, and it shows the thing, right? Because the thing is, if we didn't have this as pending, which is kind of the default case, and you wired up all this async, when you clicked something, you'd be like, oh, nothing's happening. Oh, there it is. So it is important to say, you kind of want to ask yourself, you're like, oh, wait, I need a pending state, right? Or I need to show some kind of loading state. So definitely you have to kind of opt into that. But what's cool also, all these different times, and if I click it like 4 or 5 times right here, it's not going to like jumble through it all. It's just going to settle when it settles. So they all come in together smoothly. I'm not sure what this question means. Is this actually better than per value loader? I mean, this demo is artificial, right? Like it's designed to show like a bunch of separate async streams coming together. Yeah, this is what I showed on the last stream. The difference now is this is in the JSX, right? I find sometimes that the JSX makes it more visual, because like the thing is, we've got to decide how to demo this, but like if you started making an app and you just were like, okay, I've got some data, or I got state, and I click it, I update these 5 things, and then I render in the UI like this, and you just made this app with no, other than like maybe knowing about create async, with no like advanced topic, like knowledge, I guess. The problem is most people come in, they're going to use effects for this, which is unfortunate. But if we could teach people that, hey, here's signal, and then here's async, you refresh the page, it's kind of weird. You see the equal sign kind of go in, the 2, there's like a delay between showing the value in this. You click it a few times and you're like, oh, nothing updates, what's going on? But I feel like this is the base level. But then how do you solve these problems? Well, you're like, okay, well, I need to show an initial loading state while this stuff is not loading. So then you import the loading component, right? And it shows a fallback. So now when I load it, I see loading. And then you're like, okay, well, how do I show that this is updating? Then you import as pending, and then you're off to the races. That's the design goal here of this. There's no transition. There's just consistent state. You never fetch and use effect. That's just not a thing. You just go, oh, I have async. This is a primitive that takes a promise. So you go, it's a signal promise, like turn your signal to promises, and then you're off to the races. Why is pending and pending? Well, it's because is pending takes a function. So I could also go is pending A and B. So like this should still work. Yeah, I mean, why wouldn't it? Because essentially you can ask this question about the whole expression, because the reason it's not n.is pending and end pending is the same reason that do you need to do I need to put that on every single signal? What if someone passed you a function? What if they passed you this function? What if it's props dot something? And the problem with props dot something is, how do you get dot is pending off of it? It's just a function, right? Like you can ask this about any expression, which is key. Yeah, I mean, yeah, sure. Do we want to show the n in real time? Sure. Pending. I showed this in the last example. Is pending n, and then let's show the pending n value. Now what should happen, yeah, it's still showing loading, but now it's tearing. It's showing the 5 before it's ready. See, now as I click on it, 3, 4, 5. Yeah. Sorry, that's the answer to this question. That answer the question? Yeah, I mean, it's super easy. I named them the same thing. I don't know if it's a good naming. I was just kind of playing around with it because I was like, loading is for initial loading, pending is for when stuff is updating, and then pending shows the new value, is pending is a pending. With these 3 primitives, async's done, you know. Yeah, this is uncolored async programming. That's the goal. Because what's cool about this too is like, look at the type of A. It's accessor number. It's not accessor undefined or what. The async is non-nullable. So it's not only, there's no async await, there's no null checks. Like, which is really helpful for me because signals being a function, not being idempotent, makes it a pain in the ass for like conditionals and stuff, where people are like, they get really frustrated because like, you know, like conditionals like in for loops and stuff, and they're like really angry with TypeScript. They're like, I'm inside a show, this can't be null. Well, hopefully now you won't even need to bother with the callback version for most things because they just won't be nullable to begin with, right? You design your data, you're like, this is a number. It's a promise of a number, but from our perspective, it's a number. Yes. Stuff is by default entangled together when it's on the same frame. This is something I took from from Svelte. So they don't entangle in the same way, but the idea is that the same stack frame becomes entangled. It's like your event handlers are wrapped in a transition. And at first, I was completely scared by that until I saw Rick Hanlon's talk where he was trying to convince the React ecosystem that literally they should wrap all their design systems, all their event handlers in transitions. And at that point, I was just like, if we're going to go tell the whole ecosystem to migrate, why not just build it that way in the first place? This will make life infinitely easier. Oh my god. Oh yeah, this is why Tanner lost it. I just feel like when you're using the JSX, this is just so much easier for people to see. This is, yeah, don't. I guess I'm spoiling why Solid 2.0 is going to be a complete game changer. I mean, I've been spoiling it all year, but this is just, yeah. I mean, you hope the React team gets jealous. Yeah. I always code in a way that where the value is not resolved yet, there's a loader per value within some values resolved, the loader is gone, so it's like seeing values. Yeah. Well, exactly. Well, this is the thing. When people try and do transitions on their own, they have to fork. So transitions are great because then you don't have to fork. What's really cool, I mean, there's still some overhead. I'm still doing performance benchmarks. Let me show you something. This approach I've done doesn't fork. So like I don't know if you've ever seen, no, not in here. I mean, I don't use JS framework benchmark for everything, but I want to, this just helps me show something that I want to show. Someone made React with use transition in React 19, and it's way down here in 192. Versus like where you go to actual React and it's about 150. Like React with use transition is right. This is that free? The transition only automatic transition framework. I'll talk about that in a minute. Or time slicing. But my point is that you're now back in like Ember territory or Aurelia. Like, yeah, here's Ember up here. You're not, because you're forking everything. There's a certain overhead that's just inherent to you opting into these like features with the scheduling. And to be fair, this is actually updated to 19, so this probably has the newest stuff. So this is not like the old Fiber demos. Yeah. So whereas this approach is neck and neck with Solid is today. Like basically we get this with no performance overhead. Now obviously Svelte gets it with no performance overhead because they literally use the compiler to analyze. So there's no async in this. But I've managed to design and react a system that without a compiler just works this way with basically no performance overhead. But have you covered what CreateAsync has under the hood? So if I catch up on the recording, not this stream. I talked about CreateAsync a lot more, but in the previous stream, the idea of CreateAsync though is it's a reactive computed that's async. So it takes a value in, and it let me see here. It takes a value in, a promise in, and it returns out an accessor of the value, like signal. The benefit of it is that it's graph aware because it's derived. Something reads A, something reads B. Unlike like create effect where you write to it. This is the benefit of something like TanStack. But when you could think of this like TanStack query without the cache. Like that's what CreateAsync call is. But because we have a reactive system, we know exactly what reads A. So when this goes async, we can inform the rest of the graph below it. It can propagate this knowledge, which means that we can do smart things. And I find these defaults really intuitive. Let me go back here. Do you remember Ryan Florence's demo? We all remember Ryan Florence's demo. Did it not get the new updates? Signals. What version of Signals are we running here? Signals. No, sorry, I briefly broke. Let's rm.rf node modules, rm.rf pm lock. I briefly broke this demo in version 0.84, but it's fixed in 0.85. Okay, cool. So Ryan Florence's demo, right, with the state selector. Again, loading, fallback, I'll select unchanged. Now, this is a cascading dropdown. Whenever we change the state, it loads the cities. Then you change the cities, but then we do it. So again, CreateAsync gets the states. Then we derive from the states. We get whenever the state changes, our signals also can be derived. Whenever the state changes, we trigger the signal to reset itself with the first state or the first city from the first states. Now the states never reset, so this doesn't really matter. Sorry, and then that becomes the selected state. So we reset the selected state to the first one, and then whenever the selected state updates, we call CreateAsync, which calls get cities, which does a second request, which gets the cities, and whenever cities updates, we grab the first city and make that the selected city. But obviously we can override it. So as I change San Diego, it updates. So, and then we just output the selected city and selected state. And then our select components are really easy. They're just a loop over the states to show the option and a loop over the cities. And what I did is I added a disabled is pending. So basically if I could have added a disabled to this one too, but there's no source state. But like it could have been disabled if there were no states. Like basically if the options are pending, then we disable it. That's essentially it. Like you can pull this out into a component generically. And then there's no transitions or nothing. But if you notice, when I change California, what you're going to see is San Francisco is going to go to pending, and this is not going to update till it's all loaded. Watch. New York, New York, New York. I mean, promise all settled is sometimes not what you want when it comes to UI as well, because it's blocking. All these things are blocking. Async await is blocking. You don't want to block your, I mean, you want async to block, but you don't want it to block your component code. You want it to kind of run through it. So like, I don't want an await in my component. This is doing an all settled, but it's like more advanced all settled. When async starts to update, can the component distinguish between async pending and async itself being finished, and all the children of the async are finished? It's all kind of the same thing. I'm not sure I quite understand the question. The JS framework benchmark is currently real out of date, and you want to use the official results page to get the latest from there. Yeah. Yeah, per run. Yeah, I mean, fair enough. I just yeah, sorry. I don't think this is going to change what we were seeing around React transitions versus like React hooks without the transitions. Yeah. Have you thought about then chaining, but with async nodes, like reading some async value, then another async value, then I mean, yeah. I mean, this example, the Sierpinski is chaining. Each component creates an async node, which passes to another triangle, which creates an async node, creates another triangle, creates an async node. This is that's, and when we were talking before about how it all updates together, basically async runs through the graph. I mean, I showed some earlier demos if you've seen last thing where like, I mean, I guess there's some people who haven't seen some of the previous demos that I did, like from my talk, but like, let me Beyond Signals talk really quickly on this one, just so like you can understand a bit of the nature of the nesting. If I had a component A that renders a component B, that renders a component C, and each one has their own async and reads it inside their component, like, because of the way our components run once and that it's only this that doesn't evaluate, we can still evaluate this, like they're siblings, like we don't await, we don't need to chain it. See, these are all complete in 2 seconds. What I'm trying to get at is, even though they're nested and they all take 2 seconds to load, like this one's 2 seconds, then this one's 2 seconds, and then this one's 2 seconds, they all render at the same time and fetch in parallel automatically, because we don't block the rendering, we block the data. If this depended on some data, like if C required B and then use that here, yes, it would take 4 seconds. But I mean, even me passing, let's pass B into here for fun. Like, doesn't really matter. Let's pass, there we go, pass B in for fun. And now we have props, and then we go, let's add B again here as props.b. Like, it's still gonna all render in parallel, right? Like, right? So we block on the data graph, we don't block on the rendering. Combining that with the other stuff is kind of like the whole story, yeah. Oh, yeah, the thing is, I talked about this on a previous stream. The challenge is a lot of times people with async return to like a set state. It's like, sure, they're not using useEffect, but they might as well be because they have to set a state. This is kind of like, I saw actually a demo the other day, RSC demo, where Dan Abramoff was like using his RSC Explorer, and his pagination demo used actions. That makes no sense. That's like using useEffect to write to set state. Pagination is a read mechanism. It's like it's like you with a certain, like anything you'd put in the URL perceptually is a read, right? So if you're like, show me, after this cursor, or page 5 to 7 or whatever, like anything like that, it's not, you shouldn't be triggering it with an action to get the new stuff. It should be a read. It should be like you should be updating the state, and then that's what you see. An action should actually perform a mutation, but I think we get this so backwards. It's also the issue that my concern around like remix patterns. A lot of times they're like, oh, we get rid of the updates because we don't, you can use ephemeral state and you don't need to use component state, and then you call this update when you want to. But the problem is, if you don't have derived state, if you're not like making the graph, you're going to have a bunch of intermediate states anyways that you have to write to. Like, sure, you're only calling it once with the update, but you've actually, instead of it being like a chain, you have like the multiple things. This is why I made the X state comment on that stream. It's because when you don't derive, you end up just calling a lot of sets. Start setting multiple values when a lot of times the things could like just fold out. Now, don't get me wrong, derivation is sometimes harder to track, harder to write. But once you set up the rules, you feel really confident. I think one of my favorite parts, like this demo is fine, but I did an earlier version of let me see if I can find it. I think it was in my old solid experiments thing. I did an example that was called countries. And I asked Ryan Florence to remake this demo because this one still has transitions in it, to be fair, but I generalized the select component. This is what moved me to the latest thing to get rid of the explicit transitions, because it's like pretty awkward to force the people to make transitions inside each thing and then know that these are inside transitions. Like, inside the select component, on change has to wrap in its transition, and then you like, now they're called change action, and then like I didn't want to go down that path. But the more important part here is adding the country to the front of the list here. I made some different logic where switching the country doesn't automatically switch the set of state because I didn't want to do triple cascading. The logic of deciding this stuff is all right here. It's like, okay, get countries. Whenever countries change, set the country to the first one. And then you're like, okay, get states. Get it to the selected country. And then here, whenever the states come in, just reset it to 0. That's saying whenever this triggers, just set it back to blank, which is why when I change the country, it sets it to blank. And then finally, if there is a state, get the cities for it. Otherwise, just return an empty list. And then finally, whenever the cities change, take the first city or set it to empty. And yes, there's a bunch of logic here. But if you look at my components, this is just a generic thing, right? The reason I wanted to do this, and I probably should just make this in the new Solid 2.0, is I could just delete the transition, and then literally everything works. Like I could just go on change, call on change, instead of change action. But just with a bit of logic here, generically about placeholders, saying like, hey, disable this if there's no options, or if the props options is pending. I just made a generic component that has reasonable behavior here. The logic is just the derived things. There's no calling set states. Like I remember Ryan having that demo where he's like, oh, I just want inside the change handler, I just want to go loading true, do my work, loading false. And I was like looking at this example with 3 of them, and I'm like, which loading are you setting? Like, how do you, like, because this one triggers this one's loading, and this one triggers this one's loading. How do they communicate? How do you compartmentalize that into a component? And the thing is, with these kind of tools, you can make a generic component with rules about how the updates happen. And then what's beautiful is like, the only suspense here is the outside, because the app developer is responsible for suspense boundary, not the component library, because you can't really override that. I guess you could by like playing around with async values, but I don't want to think about that. I just literally want to go, when I on change set country, on change set state, and then write some rules simply about like, hey, what should the state be? And then the rest of this just works. Like if I wanted this to auto select the state, I would just change it to, instead of being this thing, I would just say make it state 0. Okay, beautiful. Now, see, it took longer to load because it automatically thing, but when I switch to US, it's going to automatically load California. Yeah. Canada, going to automatically load British Columbia. But I didn't have to trace down all these setters. It's literally, everything I need to know is right here. Yes, we'll be able to like ship a backwards compat create resource on top, but yes. JS framework, they've been changing on single base frameworks with the latest Chrome changes. It seems I haven't looked at it yet. But you see the implication of adapting signals to be async can have an impact on benchmark, as now there's overhead to cover async. I wonder how it's planned to solve 2.0. Yeah. So just at a glance, we believe see how the states are initialized, understand the relation that code I can sell even to the hardest React bros on my team. I feel this could pretty be dependent states, async stuff. Will there be a version of create async for a stream value like WebSocket? I mean, there already is. I mean, it takes an async generator function, so you can. I mean, I think streams have a different use case. So the answer to your question, yes. I think there's a slightly different primitive you want there, but as a baseline, it takes promises or async iterables. So technically, you can just feed a stream and yield the values through, and it works. Yeah, but I mean, as we showed in our Sierpinski example or whatever, it's async whatever. It doesn't have to be fetch or whatever. It's literally, oh, I have some expensive work. Let's just do it. And what's beautiful is, yes, you have to be aware of what you're doing in this work here. But the framework, the UI part, the part on the outside doesn't freaking care. You know what I mean? Like, this is kind of like your dip into that world where you do the fetching or decide what you do. I just love this kind of stuff because like get cities here, who knows what that is? Could be a server function, right? This is why I love server functions, right? Like in solid start, you just put in use server in here, right? It's not like that's why like actions and like I think we have to be very careful on the language on the stuff. I mean, that's a whole other tangent, but like, yeah, this just feels really good. Now, obviously, I'm not done, so maybe we'll realize something in the course of the beta testing for 2.0. I'm still missing the last couple of like action-based and optimistic updates on this new branch. I haven't implemented those yet. I have them on my previous branch here, but I gotta give it this felt. And I guess Dominic Ganaway in chat deserves a big thing because I hear he was a big influence on Svelte final solution here in terms of like, where they ended up. And then just pull in a bit more of the React influence, and I think we end up in a really, really cool place. Should one show errors or error boundary or returning some error as a value from create async? That's up to you. But it's so funny. I feel like I redo the same demos every week. I have a demo for this. What's up with this one? I don't remember changing anything in it. I hope I didn't. Oh, right, I did. I I had to update it to the new version of Solid. Yeah, let's go back. Collections. No, collections. Solid experiments. Error fetch counter. Dev's original example. I think you could make it a value if you want to, but error boundaries are great, right? So we have our loading, then we have our error. I'm playing around with like simpler names, but this is basically Dev set up this thing where you get a phrase and like every 30% of the time it errors out, right? And this is the updated version now with the transition stuff in here, right? So basically when we load in, and then when I click this, transition, right? Because there's an is pending here, yes. Style is pending upper phrase, sets the opacity, and eventually it's going to error here, right? Eventually. Okay. Now, clicking the next number updates the graph but this error boundary is showing this message here and passes in a reset. Now, clicking the next number will reset the reactive graph, which will remove the error, but it's still under transition, and then we get through. But also, calling retry uses the fact that the error you return, it knows it was an error in the create async. So like, and this async is actually derived from memo. So you got phrase, and then upper phrase is phrase to uppercase. Notice no null check because again, phrase is a string. It cannot be it's not null, which means that upper phrase is also a string, not null. But if something happens and it errors out on this upper phrase and we click retry, it will try to it collected the effect that failed, which is specifically actually in this component right here, props.text. It collects this effect and then it tries to get the value again. It like looks up the graph, and what will happen is we'll trigger transition and it will fix itself. It'll actually fetch the data again in the background. And you're right, you could have returned a value, but then you don't get this ability. If you actually, the graph understands that if an error happened in the past and it needs to recalculate it, it should try to recalculate it. It doesn't cache the result. It kind of breaks the memoization. So one of the cool things is the error boundaries have the ability to collect the errored nodes at the bottom and then pull through the updates. Will there be able to put create asyncs in stores? You could use the getters, but I think what's more interesting is the idea of creating async stores. Like the way I use it is I actually derive stores from async, generally speaking. You can use the store as a diff, but it's instead of having specific, like, sure, you could have a store, like a giant store, and have like derive a specific value from an async value, like use the getter and kind of isolate. But in that case, the store is just a container. It could be an object. It doesn't really matter. What's more interesting is if you have async sources that can do fine-grained updates on stores. And I haven't updated because I don't have the action part, but I have a to-do app that kind of shows this potential here where we can combine it with optimistic updates and get fine-grained optimistic updates. And then when the data comes back from the server and diffs and doesn't see a change, it doesn't update anymore. So the store story or the local first story with this is actually really cool. One of the things I've been working on, we talked about async generators in create async. Well, that sends back a whole new value, right? Each iteration. What if each iteration just wrote to or updated part of a store? So you can progress the fine grained all the way through. So we don't have a primitive that quite works that way yet, but it seems reasonable that we could basically derive stores from streams and then only stream in the parts that change instead of doing any diffing. Could React introduce implicit transitions if they wanted? Maybe. I don't know if there's a performance cost. I mean, they have to do the render anyways. It was hard for me at first to figure it out because cloning was kind of expensive. But now that they're not using it for prioritization, maybe. The other thing is we support parallel. It's hard to do implicit transitions if everything entangles. They only have one future transition at a time right now, I believe, or at least one per create root. Because we have parallel transitions, again, I have a demo for this probably somewhere. Let me see if I can leave. Where is it? Multiply. Oh, I haven't moved this demo over yet. We'll see the old version of it, which is where was it? Oh, I don't remember. I showed it on oh, but then that wasn't the JSX version. I have a very simple demo that's like, go back to my profile. That's like async holding and then parallel async. Yeah, we'll just use this for a second to kind of show off this demo. But what I was pointing out is because of like, see how these are still independent, even though we have two separate transitions in flight. This is, I think that's another piece that's kind of important if you go implicit. See, Svelte solves this by not actually having transitions. Like I think I showed in the Svelte version of the demo that here that like the multiply demo that I was just doing. If I click this like 5 times in Svelte, you're going to see it update 5 times. Sure, it waits to make sure everything is consistent, but if I click like da-da-da, you like depending on how long each one takes, they kind of all just, you know what I mean? Like I think there's some, yeah, I think you need to be able to support multiple transitions if you want to get there. They could get there. It is theoretically possible, definitely. But yes, compatibility issues is an issue. This is a breaking change. This is like when React changed the set state. Like Solid 2.0 behavioral. The funny thing is the breaking happens in the event handlers. It happens outside of the system. Inside the graph, everything's consistent anyways. But yeah, this is kind of a big breaking behavior change. But I mean, I think we're still at a point where we can be bold. It's, you know, I get it. It is a change. React probably can't easily go here. Instead, you have to, I don't know, will every component library go and wrap every event handler? We'll see. Again, you derive it. I wish I could show examples, but the key to a lot of these patterns is you derive it. See how, yeah, right here. I'm setting count country 0, but what you see is if I took create async and then I wrap the countries in a signal that derives from it, then I can override that value. So even though this initially is country 0, I can change this to United States, and I'm basically writing to that. So to answer your question, the async primitives we have here aren't writable directly, but you can always derive from them and write to the derived. I don't know. I did that because I didn't want to have all these combinatorics like create async memo, create, you know, like all the create signal. But I actually think guarding this way is important too. I usually there is no like is pending, right? You know, like dot is pending or dot pending. The one exception I have right now is there is a countries dot refresh. So if you want to re-trigger your async, there is a hanging method on the async primitive that makes it special. That's the only one that has it. If you look here, country, see the refresh, there is a countries dot refresh. So we'll see if that sticks through all the beta, but generally speaking, you can always just derive it. And the fact that deriving this, I love this. The fact that you can use a signal now, you can have derived signals, just makes this whole thing just lay out really nicely. Events already wrapped in start transition to what React calls actions, yeah. Okay. Yes, but the problem with that API is this is different than the other case. The problem with that API is, what if someone just passes a function? Do they have to like it needs to be Yeah, I mentioned earlier that with errors we could pull through because we know that they're errored and it's valid. I can't take something downstream derived from async or like a function wrapped of a function and be able to tell it to refresh, because if I pulled on it, it would hit a memoized value and go, okay, stop. Like I have a value. So refresh actually has to start from the top. So it has to be the create async. If someone had props, like passed countries through as props, then I lose that. So I can't, this API shape doesn't work. I mean, you can refresh something that's still loading if you want to. Just like I can click faster than the loading comes in. I was having some fun with Dev's example the other day, where I was like clicking the counter before the loading boundary had finished. Yeah, I really should remake this to demo. I'm really digging not calling the suspense side note. I know it's funny. There's just something now for me that just feels so natural about. Let me go in here in Dev's example here, but it's this one. There's something that feels so natural now when I look at this around just like loading and errored. Like I don't know. Maybe errored isn't the best name. It's shorter and it's like to the point. You're like, I loaded this app and I started up this app and it looks all janky. How do I mean, I could call it placeholder, I guess. Whatever. I think this is the term you search. All right. I don't know. This is what I wanted to cover. So I think we should probably move on to this week in JavaScript and the other topics, unless people have any. Yes. Creates signal if you pass a function to it is also create memo that's writable. Yeah. This is one of the key pieces. I wanted to make sure that people never use effects for synchronizing state. And from my point of view, there's 3 ways you do that. Well, 4. There's four pieces to that puzzle. Piece number 1. Have signals that are derived. That's hard in state in React. Like they tell you can just update, but if you read like the React docs about like don't need an effect, just write in line in the component. Well, our version would be write it in a memo, right? So you need to be able to have like this that I'm showing, right? Second thing, you need a way to do data fetching, create async, right? You don't want people to like fetch in effects. Third, you need a way to write to stores, like more granular spread thing. That's why we have derived stores. That's why we have projections. And then finally, make using useEffect as painful as possible. And I think I've accomplished that by making an API that even React devs would hate. So I think all of those things together really get us there. No, I'm kidding about that. The effect API is important, but if you notice, in my examples, I've been splitting it where there's a reactive function and then there's the effect separately, kind of like the dependency ways or watch and view. But like, I also have a version that can handle errors separately. If you notice, this effect erroring doesn't trigger an error boundary. Whole other conversation. But the idea is I wanted to give effects more power, but at the same time, make them much more special purpose. How does Solid 2.0 compare to View Vapor? I don't know. View Vapor is basically Solid 1.0. Like I mean, it's hard to compare. Like the Alien Signals is a faster reactive thing, but View Vapor is basically what we released in 2018. Solid 2.0, we're kind of going a completely different. I'm not saying that View doesn't have other features that we don't have and they don't have a more advanced thing, but the core thing that View Vapor is putting out there is what Solid's had from the very, very first version. It's been great work, Begin. Thank you. Yeah, it's been tricky. I go through moments of wondering like if this is even possible, to being like, okay. So I mean, we're getting there. I do feel bad. I was ready to ship the previous stuff when I did that talk back in September, October, but I spent the last couple months getting us there, and I'm not there yet. But I'm sorry. I was expecting like a beta release this year, and it's not going to happen. But we I'm getting there. You know, we're a lot of work from different members like R3 with Milo's work and kind of refining this. There's a lot of cool little hidden features we're getting to, like automatic disposals, which actually broke my tab demo that I have to look into. But we all those things that like this isn't created inside of root will be limited to certain types of primitives now, like effects. We have auto disposal memos and stuff. It's a lot of great work from other people, like Alien Signals guys actually influencing Milo's work, and then R3 and all that. Yeah. Yeah. Like if someone I mean, MobX has this already, but if someone stops listening to something, then it gets disposed of on the drives things. The only thing that needs explicit disposals are basically the effects, which need to be created under a root, essentially. But it means that like people can just like make people could always make global signals, but we weren't like other signals libraries do this like for years, but our derived values, like our computeds or whatever, you had to be under root because otherwise they wouldn't get disposed. The biggest problem with signals-based systems is that it links both ways. So if you have a long-lived signal and you stop, like you have to actually explicitly unsubscribe from it or like remove it. Otherwise it's going to sit like the thing listening to it, like some computed value, is just going to sit there forever. And for the most part, the UI does that for us. But if people, made things globally, or like, did something weird, like create something in an event handler. I don't know why they do that. That's why we had this warning. But now if someone stops listening, then it detaches that part of the graph. Unfortunately, there's a missing case I'm somewhere right now where with my deferred disposal with like transition tab, like UI navigating, it's disposing too soon and it's breaking one of my demos. But once I get that working, I think we'll be in a good place. Okay, that makes a lot of sense. With eager streams read, so if the concurrent throws away the component, yeah, and it's awkward from MobX for the same reason it would be awkward in Solid in that MobX does have automatic disposal, but once you dispose, you have to redo all the work when you subscribe again. So if you have something like React that's being kind of ephemeral, which is just like kind of like going, oh, I'm just going to render it, then I'm going to dispose or render it. You're actually, instead of the graph keeping its value and being good, you're like causing MobX to kind of have bits of fits because it's like, okay, I do my work, okay, I'm good, and then you get rid of it, no one's listening, and they're like, okay, good, I can release, and then you come back and you're like, I'm going to do the work, and then MobX, so okay, I have to recalculate everything again. Yeah, there's different like timing. It's like how long do you wait to dispose? The end of the propagation, the end of the current frame, the end of async, the end of what? Feeling that adding JS made this more real for chat. Welcome to the excitement club. Yeah, it's so funny. I posted the first version on here and so powerful, blah blah blah. And I'm like, this has like 65 hearts. People are like, I haven't posted like the actual demos on Twitter yet because I was like some of them are broken. They're changing between versions. We'll get there. I'll get to a stable place. But when I post this, like I don't think anyone understood what the hell I'm talking about on these demos. Like, because I was just like, I mean, I still love that I literally hand bake this thing. Like there's no JSX here. Like I'm literally this is like what solid compiles do. I just literally here's the logic for this thing. I made a component. Guess what? It's just a function. This way, create a DOM element. This way Solid deconstructs is really educational, but for a lot of people, they don't picture themselves using it. It's just funny that this code here that I wrote is basically what the final states demo code probably generates. Like that code is this code, It's almost one for one. Would we ever have a memory space somehow? Maybe one-time installation in JavaScript engines that gives us the book service over one day. Yeah, I'm not sure. It's weird with like JavaScript's a weird language. The way like everything is dynamic and like scripted, and it has to like be discovered. It's one of the most it's one of the more dynamic languages, and the fact that we have any expectation around it is crazy. It is like the perfect kind of mess for the web, which has to handle messy stuff like this. Sometimes a messy language is a good tool for a messy world. Anyway, let's switch gears. I'm gonna get ready for this week in JavaScript. Give me 2 seconds. I'm just gonna flip to this view. Keep on throwing questions in the chat or whatnot. I'm perfectly open to answering those in a second here. Also, what was I gonna say? Oh, right. Like, comment, and subscribe. Really gotta push this on the stream. It's funny. I really don't push it enough. And if you're around, yeah, it definitely helps. Okay, when was the last time I streamed? I guess is the first question. Go bookmarks. I have so much open stuff right now. Just trying to close down some of these windows. All right. All right, this book. All right. Like this bookmarks in Blue Sky. I've only ever bookmarked one post in Blue Sky, and that was Rich Harris's forking post. Watching these styles together is so satisfying. They have the same, of course, this is how it should always work, the elegance of signals. Yeah, I mean, that's really what I'm doing here. I know it's taking a while, but and now it's kind of more in the open and people are watching, but I feel like when this lands again, it's going to be like the same thing. Like Solid, it's so funny because Solid changed so little in 7 years, and now we're talking about big changes again. And most people are just like discovering it now. It's kind of funny. It's like people are like, "Oh wow, this is so crazy. This is the way it should all have been, and this is really awesome." And it's like that's like for me, it's actually even longer. That's like a decade old for me now. It's like I'm ready for the next thing. I hope it happens faster this time. I hope you all are ready for the next thing as well. Scheduling window, playground. Okay. All right. All right. All right. Okay. Cool. Okay. This, and then I'm almost ready. Give me 2 seconds. When was the last time I streamed? November 21st. Wow. Okay. Has much happened since November 21st? I guess we'll find out in a moment. Oh yeah, there's some fun stuff. Dun dun dun, and then although to be fair, I haven't been as busy myself. Okay, so let's get going here. The problem is, it's not the problem, but we have to realize is I'm very close to being like finalizing the features on the client side, which is what I thought I'd done a couple months ago. But then we have to apply everything to SSR. So even though this is like this is why I have so many phases, like multiple phases here. With the client side stuff is like getting very close to being like, let's RFC it, let's stamp it, let's get the feedback, let's work through it, let's see if this works for real applications, let's try integrations. But the server side stuff is actually also a fairly big update, probably, although change R3 changes everything again. So yeah, you're only seeing half the story. So yeah. Okay. This week in JavaScript. Let's get going. Start with some solid news. I talked about this previously. It's always cool when Dax, draws attention to it. But he was really excited because he built his whole company on Solid, like terminal apps. Like people talk. I still to this day, people are always like, "Hey, React's advantage is like you can do things outside the browser. You have like React Native and Ink and 3GS. People don't realize that it's just as easy to build those kind of things in Solid as it is in React. Like people are like, oh, you need a special compiler, you need a special thing. Like the reactivity, while I show the DOM stuff being specialized, you can generalize it. Like while the compiler isn't the standard solid DOM or SSR compiler, we have a third compiler that it's basically the catch-all. Like we could make everything use this third compiler, but then it wouldn't be as optimal specifically for the DOM environment, right? Which is what I focused on, or for SSR. So the way you should actually view Solid is there's a generic compiler, and then we've made specialized compilers for DOM and for server. So like it has all the same properties as React does in terms of that. And you can even interchange elements like DOM and Canvas together and all this stuff. Like other compilers together. It's some work Nikhil did a couple years ago, which is amazing. But it means is that Dax is using Solid in the terminal. He's using Solid on the desktop. He's using Solid on the web, and also for enterprise. People don't realize this. Like Solid outside the browser is like more common. Cursor is a perfect example, right? Cursor, everyone knows that Next.js is their Cursor web app. But when you're using the Cursor IDE, like on your desktop, that's Solid. So like, this is just awesome to see. Obviously he's talking about our growth. I didn't realize it's 6x. We went from last year at the beginning of the year at around 250-ish to now being over 1.2 million downloads a week. So yeah, Solid's growing at a nice clip. So thank you all those people, companies, that have been adopting. Like there's been a lot of really nice growth. Some large companies too, like Bloomberg and like obviously Xfinity, Comcast, Universal using us on television apps. Just really nice solid growth. Oh yeah, here's one. Bell launches new 5 TV app built using Lightning.js and SolidJS. Millions of Canadians will experience Solid daily. Yeah, that's awesome. As I said, the TV apps, it's funny. It's actually, everyone assumes that this is a weakness of our approach and that we should, this is why I use React. We get used probably at larger companies more often on non-web stuff. Like, yeah, it's kind of funny. It's not that simple. I have, if you guys aren't aware of my funding, I get paid by Sentry, and before that by Netlify. It's not like stock options or whatever. I don't have I don't have like traditional investors. I don't have a company. I literally get paid a salary working for a company that lets me work on open source. Similar to the deal Rich Harris has with Vercel and whatnot. We're not owned by the company, but we're given leeway and license to be able to work on our projects, which is amazing. I sold my eBay. Think about when I worked at eBay and the tech stuff. The eBay options were fine, but I did not make much money off of them. I know that was a joke, but yeah. No, that's a thing. I didn't even know until this CTO reached out to me or whatever, and I talked to him and I saw the code base, and then they started trying to hire people on the core team. you know, at some point that they you know, are like looking at like, we're, you know, I guess they're also seeing if I want the work, but I have such a great deal with Sentry, you know, but like, yeah, this is the thing. People, yeah. You can't be acquired if you're not a if you're not a company, I think. Yeah. Yeah, no, and the fact that I've been able to have two jobs like that in a row, it's amazing. Netlify and Sentry. Clearly, there's people who believe in what I'm doing. I think it's like the long shot bet, honestly. Tanner, kind of similar situation, although he gets to funding from different locations. But I think there's a lot of goodwill that comes from it, and a lot of my research ends up helping more than just like it has a ripple down effect that creates goodwill across the board, which I didn't realize at first. I was actually talking to Adi Osmani at the conference recently because I was mentioning how Google's funding of Solid actually really helped research that would lead to work being done on like Cerevel, which was our serializer. And like, in a sense, like you can't look at stuff like TanStack Start or even some of the newer features in FeltKit and not see Solid's influence there, right? And like the ability to kind of build out this stuff and have it kind of trickle out into the ecosystem is I think it just net positives. Like even like the server component feature that they're working on TanStack was influenced by work that I'd done in research into server component approaches, right? So like everyone practically realizes that React's popular, they have to use React. Everyone wants a lot of people want TanStack to succeed. So in a sense, by supporting my work on open source and Solid, you're actually also supporting TanStack as well. For example, like in terms of some of the design stuff that comes there, like, and they're supporting us right back again. If you want to talk about download numbers, a lot of that comes from the exposure Solid's getting through TanStack DevTools. So like, there's like a nice alignment between a lot of parties in open source, you know, where, you know, who knows, maybe in the future you take your React app, you move it to TanStack, and then you move it from TanStack to TanStack Solid, right? So like this is kind of, I think there's people who are interested in alternatives to React, alternatives to Next.js, all actually end up aligning and wanting the work, even though I'm like as far upstream as it probably possibly comes. The work that we're doing on Solid and myself they're doing ends up probably leading to that eventuality. Like it helps. To be fair, the guys from Cursor have found some issues that they want to work through in terms of some performance pieces, but the type of ways they're using stored and stuff might not be correct, and we have to work through that. Their biggest problem was actually TypeScript, ironically. They're using giant stores, and because of our typesetters, this is fixed in Solid 2.0 because we have a different API for the setter, was actually causing problem. It wasn't the actual performance of Solid so much, but that their TypeScript compilation was taking so long. Yeah, anyway, yeah, but mechanically, yeah, I mean, highly interactive stuff, embedded system. This place makes a lot of sense. I mean, Netflix was looking at us for a while until they realized the migration for React was going to be a little bit too hard. But I think it's a great option for a lot of green. I always hear about these like little side projects from Apple and all these like things. We never get the front page web stuff. We always end up with like the crazy performance people who need stuff to happen. Yeah, yeah. I mean, the TanStack team are paving the migration path. Yeah, I mean, part of it is the sheer amount. Part of it is there's a couple of things that were designed that I thought were impossible for TypeScript to type. Someone figured it out, but in a very expensive way. You know, places that can be improved. Yeah, I heard there's some Vue libraries coming in Svelte into TanStack, especially like Start, which people are excited about. I think Sebastian Lorbe, the guy who does the React Wiki, he's like, now they're framework agnostic. It's like, no, guys, Solid's been there since day one. I guess it wasn't so obvious because there was no announcement, because literally it was implied when a new TanStack library comes out, it comes out for React and Solid. Okay. Yeah, what other interesting demos? Durable streams, TanStack DB plus SolidJS. He just did it for fun. They just tried in a different thing, but this is a perfect example of showing where the Solid and TanStack, is just, he didn't use React just to do demo. So there's a comment is like, are you using Solid much? He's like, no, not really, but not really, just did Wim for dollars. Some community members did integration DB, so it's pretty easy. Yeah, you know what I mean? I think this goes to what I was talking about earlier, whereas if all the expensive or tricky specific logic is in create async and the rest of the framework just renders, like outside of the create async call in all those demos, it just looks like synchronous, plain, solid, super easy, then stuff like this is really easy because Kyle can just take a demo that doesn't need transitions or weird or whatever, and he just writes the logic the way he expects it to be, and then all the work is in that wrapper, essentially. Like whatever they wrap TanStack DB over create async, that's where all the work is. And then seriously, you're just taking TanStack DB API and plugging it into, or with the stream support, and then plugging it directly into a very basic user interface that is designed to be rendered optimally by default. It's just win-win. I've been saying the local first story is just like, it's just, this is where things really go into new gear. Okay, let's continue on. Let's look at bookmarks. I'm going to go back to this one in a minute, but this is an interesting conversation. Let's see what here is. Oh yeah, this one. React is slow. This is 3JS running in the ecosphere, rendering real-time 8,000 things. Here's Shopify and just how we pulled it off. Then why do you have this callout? Is it slower than plain 3JS? No, there's no override. Components render outside of React. What's the next sentence say? 3JS and scale due to React scheduling abilities. That time slicing is awesome. Can't have time slicing with a render model that allows it no matter how the components rendered. Oh, that's being cheeky. What kind of render model allows it? Or I guess more importantly, what render models do you think not allow it? Render model for Vue, Angular, even Solid, correct me if wrong, is to compute and apply all DOM dates a single tick. You can still do slicing, of course. You just have to cut the slices yourself. How is React model different than compute and apply all DOM updates in a single tick? Oh, we talked about this on stream. Sometimes on Twitter, this doesn't come across properly. Dev's right, though. It's hard to get to the nuance of it. If the compute part takes 200 millisecond large 3D and the DOM update gets deferred, this means the browser still outfire 10 to 10 image frames while rendering. In the other frameworks, button while rendering work completes. But by interrupting the work, you don't render the lower priority stuff until you hit some sort of threshold or input stops. Time slicing ends up spinning its wheels and then throwing away potentially multiple times. The end result can be smoother in some ways, but also prone to latency as responses ends up dragging. Seeing things seize up and then updated in bursts, things look like maybe they are mostly updating but delayed, maybe a couple 100 milliseconds, like it's moving slow motion. Honestly, neither is a place you want to be. Now, I take time slicing, I think if it didn't come at a cost. I implement time slicing, blah, blah, blah. What I found was that the threshold in which things get weird happens a lot quicker because of the overhead of the mechanism itself, and by similar consideration, there are ways to reduce the overhead of work of process itself, considerably better results. If you don't expect to exceed the bounds very often or rarely, burst seize-ups feel fine. Expect to hit all the time, you should fix what you're doing. Yeah, I think this is kind of a summary of what we talked about on stream. I think 3D is an interesting area. Yeah, let's talk about this for a second. In that there can be considerable costs in setting up the scene graph data. Things that happen off screen, things that become part of the pure render, which in the browser wouldn't be our responsibility. So smoothing over these burst allocations is actually nice. I think the thing we often find interesting though about things like React 3 Fiber is that in order to get the performance generally, you do granular updates outside of React's update model anyways. Yeah, like they don't call set state to update the stuff. They have their own update timer. Like React is only there to set up the scene where the time slicing is helping and then bypasses for updates. So when Used as a performance example for React, it always feels suspect because the most glaring fact is the updates escape React's update model. Time slicing is nice here, but almost a product of the abstraction in the first place. To be fair, every framework needs to render on creation so they are impacted. But if the parts of the scene graph that weren't represented as components, then we could break them out of this synchronous lockup. What I'm saying is if you could just pull the expensive stuff into like create async, pull it out of the rendering, then you don't need the time slicing initially either. It's just odd to use an example that is basically poses the model at every turn as performance example. Yeah. What I'm saying is what I was trying to show earlier with the Sierpinski examples, I actually think that this basically suggests that we don't need time slicing. It's always interesting because like these kind of updates almost never have anything to do with React's performance. React just sets up the graph, and then the splitting helps there. But if you could just pull the graph setup out of the component rendering, then you don't need the splitting in the same way like I showed. So I think this is one of those places where this perspective is going to change. I want to point this out because this is like another example of like, oh, time slicing, you can't do this any other way. TanStack is using creative areas or something. Yeah, that makes sense. Where do TanStack start and solid starts fit long term? They seem very similar. What's their distinct role? Why would TanStack start just be the default? What do they do differently? Well, the problem is we need like a create VDAP for Solid that supports SSR. That's why I made Solid Start. I don't care about the advanced features. The problem is to get all the pieces together. There are things you need, like SSR. Suddenly deployment becomes a thing. And the thing is, I wanted this design primitives that were specifically designed for Solid's uses. TanStack's great in that it's general and it has like way more stuff and opinions and stuff. But I need something more core, like things that I could pull into Solid core itself. Like the hardest thing is if you have to build an adapter for Next.js, React Router 7, or TanStack. Like you have to build 3 different adapters right now if you're Clerk for auth. I don't want that to happen with Solid. So I'm intending certain pieces I think actually belong in the framework, like having a shared request model so that like the router can tap into it. I want to make it so that any Solid router can work in Solid Start because I want to make it that any Solid router can work with Solid in all these scenarios so you can build any meta framework you want. But to do that, certain pieces and certain interfaces have to be established by the core framework itself. And so Solid Start is designed to be Solid specific starter that aligns with all these feature goals of all the features fitting together quite nicely. And very primitive. It doesn't care about like, oh, you want a special validation library, go use, obviously I love Valibot here, but use Zod if you want. Like, go ahead. We're not going to make those kind of decisions for you. We just need to look at things from a very primitive level. I don't even want to tell you which router to use necessarily. So like, generally speaking, TanStack Start is always going to be more opinionated. I'm hoping there's a future in which TanStack Start is just some opinionated wrappers. The same way you wrap create async for query, you wrap these primitives that we built in Solid itself, or even anything that can stay within Solid Start in TanStack Start. But my goal is to make Solid Start kind of shrink over time, as responsibilities fit into the right places. But there's definitely like that core piece. Like part of Solid Start exists because of, say, deficiencies in Beat itself, for example, things that are missing. They add the environment API, suddenly those things shrink. But like server functions, they have to come from somewhere, right? Maybe they're just a V plugin. Beautiful. Now that piece doesn't need to exist. TanStack Start and Solid Start are very similar, obviously, because TanStack Start's design was basically based on Solid Start. It's like literally our architecture just moved in a more generic way, right? The whole isomorphic data loaders and the server functions and the single flight mutation potential and like all those pieces are basically the cornerstones of what makes Solid Start's API design. So obviously aligning these projects is fairly easy. But there's a lot of like the details in the implementation that has to happen while we continue to do the updates. So the biggest thing is like originally I was spending a lot of work in making stuff that didn't exist, and Nikhil was, and then Stack started by just using the stuff we built, and then they're like, things have changed. We can do better. We can cut out those pieces. We can do stuff, and they rebuilt it. And then we're taking pieces of their stuff back and using it, like the server function plugin. That's where I want to go. I have no ambition in a sense, you could say that Solid Start could melt away, but we still need a CLI and we still need a way to start solid projects with SSR without saying, here, you have to use a framework. I don't want to tell people they have to use a framework ever, really. So, these projects have distinct purposes. I think for a lot of developers, they'll just be like, yeah, TanStack starts exactly what I need. I want to opinionate. I want it just to work out of the box and just go, and they'll go use that, and we'll be using a lot of the same pieces. But for other people, they don't want to be told what to do. I'm one of those people. I hate being forced to opinions to a certain degree. Obviously, I have opinions, so there's always going to be things you disagree with, but trying to keep those to a minimum is like part of the goal here. So yeah, I doubt we're probably not going to default to TanStack start that ever. I mean, I don't mind it being a choice, but we still need like a base template, at least from my perspective. Okay. That's why I don't I just bookmarked this because I thought it was funny. That's the same guy who gave us a demo that we were using for time slicing earlier, which is very helpful. Apparently doesn't like us. That's why I don't like the community around SolidJS. Arrogant, selfish talks is built on an anti-React guys. That's funny. Brought in from the author, Ryan Carter, his marketing for Solid. It's so funny. Are we anti-React? I guess from the perspective that if we want to succeed and we want people to choose using our project, then we're not necessarily always pro React. We have to disagree with them on, certain decisions or certain design points. But I have a lot of respect for React and the React core team. I wouldn't, have Ricky on stream or jump at the chance to talk to Dan and stuff. Like if it wasn't a matter of like, the great work they do, that it's influenced our work a ton, Probably shouldn't waste too much time on this guy. Clearly doesn't know what he's talking about. Yeah, it's trolling. But I just don't get what people get out of doing that. I don't know, whatever. Maybe this works more on people who get angry about stuff and then they get to them, but I don't know. I stop sometimes to think of like if this is the kind of stuff you write on Twitter, like what do you do when you're not on Twitter? I don't know. Maybe I worry about other people too much. But Bun is joining Anthropic. I don't have a ton to say, honestly. Theo covered it better. I flagged this because it's interesting. What's cool is Bun is like, and Jared is like my kind of guy. You know what I mean? He's fine. He's running a company. He does that. I think he gets to focus on the engineering again is just like probably the best thing. I mean, he's more ambitious than me in terms of running a company, but I think he's probably very happy where he is now. Thank you. Yeah, that's fine. I only flagged it because it was interesting. Whenever I see something that's like so like negative, you're gonna gotta like stop. I think there's an article I saw a while ago that's like Solid is not the future or something, and it would. Can Can I even find it anymore? SolidJS is not the future. Yeah, here it is. And I was going to cover it on stream, and I'm not, but I read it and I was just like, you can't even really engage with it. I agree. This entire discussion is pointless and stupid. Because I was going to like argue with the points they were making, and then I was like, it's tricky. You have to like, in order to actually talk about something in good faith, you have to at least like, there has to be good faith to be able to talk about something, right? So when you read something like that and you're just like, this person is either like the stupidest person who's ever lived, or like there's no common ground. You can't even have the discussion, because you're just like, this person must be coming from like some alternate universe where like up is down and whatnot, because like when you there's no way that someone is like, you know what I mean? Like, yeah, it's hard. It's basically no thing. Yeah, I mean, prioritization, but I mean, I don't know if Bun was always the best at prioritizing. Jared is kind of a loose cannon sometimes. Like, did you ever hear the story about like the day before he released open source Bun, or like 2 to 3 days before he wrote a SolidJS compiler, you know, just for fun? Instead of focusing on bug fixes to get that out the door, he decided to write a SolidJS compiler. You know, that it wasn't fully featured, but it was just like a proof of concept. I just said, let Jared cook. I don't know. I doubt they're going to change the core aspect of the open source and like the core aspect of what makes Bun like so them influencing direction. Like, we just need the runtime to be well tested. I think that's the most important thing. We need it to be solid. Yeah, I'm sure there's going to be Anthropic specific stuff and like runtime. Like, they're going to go off thing, but the most important thing for people using Bun is that it's stable, right? Like, do you guys find Bun is missing many features? Right? Like, they were making like their own Redis and stuff. Like, if they're already doing that, you know, I don't care. Like, go help spend that effort doing something for Anthropic. That part's like tertiary to what I'd be using Bun for, which is it's bundling, it's a package like install thing, and it's runtime. Like, whatever else, you know, whatever. I guess I'm not like a huge Bun fanboy, so I don't really care. I want the fastest runtime. I go to Bun. Let's move the banner for a second. Oh yeah, Ryan Florence performance benchmarking arc. We can do that in a minute. Maybe before that I should look at one more thing. This is a kind of interesting thing. I often find really interesting posts. For those who don't know, Aaron is CEO of Roshi Corp, you know, like Zero and Replicache, and you know, and he makes really astute observations, and this one is kind of a funny one, and this one I wouldn't mind putting out to the chat to see what like where you guys fall. So basically, software engineering likes to crash early, and ops likes to degrade gracefully. I think this exposes something kind of interesting about both disciplines and subtle about running software at scale. It's a very important thing. And in fact, when I talk about framework design, I like my software to fail early. Do you know what I mean? Like, I don't want my React app to get slower and slower over time because of re-renders I don't notice. I'd rather the reactivity just stop working the second I make a change. But there's a certain practicality here. Graceful degradation, which is something that React spends a decent amount of time supporting, time slicing. That's the whole topic of the stream. you could view time slicing as graceful degradation. Is actually fairly high React priority, where, you know, when I'm designing stuff, I do like it to crash early. Right, in before Erlang, right, because aren't they the set thing where it's like basically not possible to write wrong code? If the code's wrong, it just won't compile, it won't run. Right, React compiler, yeah, that's another great example of like it's like optimizing to try and degrade graceful, like all the stuff to prevent you from just writing the right code in the first place. Like, or not even write code, like remove the ambiguity of what is right or not. Or letting me say let it crash. Yeah. And also I think there's more to it than that, right? Because the Erlang, the stuff can like also like be stopped and resumed and moved across. Like it's very portable, it's very modular to the process. Supervisor will just start another one that will crash again. Well, yeah. Yes. Yeah. Yeah. Because it's isolation to handle it. But this is a very interesting fundamental kind of question, right? Like, because I like crash early, and I think most software developers lean towards that but then when you become a product manager, or they say ops, but people, when you're on the other side, degrade gracefully is what you actually want, and these things are fighting with each other. I think this whole thing could actually be the fundamental gap or difference between perspective on like why like say SolidJS is a engineer's framework, so to speak, because like we cater to software engineers where like crash early, whereas like React and the role of meta, like they've been forced to worry about degrade gracefully. That's like really important to them. And when we look at them, they're like, how could we not look at that and be like, that's craziness, right? Idealism versus reality. So by that scope, we're the more idealist one, and React's the more realistic, which is funny because a lot of people paint the React team as being in their ivory tower, being like sitting there and going, oh, concurrent rendering, algebraic effects, time travel, time slicing, they're just making up stuff to make things more complicated. Or maybe not. Maybe they are actually trying to engineer for a reality that isn't so clean. But it's also like where the values are. Software engineers don't want to return incorrect results. Rather be down than do something wrong. Yeah, this is true too, right? There's probably an unstated bias towards having a debug trick corrupt state bugs. Oh God. We had a bug at one of my old companies where we were basically deleting data, not the photos, not the assets themselves, but deleting data records. And like it was happening really weird thing. It was like a bad SQL query kind of thing, but it was very subtle. It only happened in a certain thing, and it was generated from the ORM. And like, it turned out that I was missing an S on a table join schema thing. Anyways, it took forever because it still kind of worked, and it was like we had one of those kind of Rails like auto generating thing. It was in JavaScript. It was something called Backbone ORM that I worked on. Anyways, and it took us weeks to figure out because it's so subtle and we didn't notice at first, and people complained. We're like, are you sure? Like, you just hallucinating things? But then we had logs and history that be like, the stuff's actually missing. There was a user action, and it took us forever to figure it out. And like, as a software engineer, 100% would prefer if the thing just crashed or errored on the user than kind of worked, because over those, there's no way to unwind weeks of subtle changes. You don't know what was the user did or what happened accidentally. And when you're looking at something, debugging it, and the state it's in makes no sense, you're like, this is impossible to get here. Like, that is the absolute worst feeling in the world. Yes. Ops people will win the night at the website dev, but the devs will have a device way to clean up the silent data corruption. Devise a way, yeah. I think React needs to focus on grid because it's easy to do the things the wrong way. Right. I mean, and that's part of the ambition of the DX. Right. I never understood this until I had that conversation with Dan at the end of my Signal article, where he wanted developers to be able to just like write to some temporary state in a for loop in the middle of a component, and then we like talked about expanding on that. And I was like, just freaking declare the state const, like write it as derived. I still use that example to this day because it's supposed to be intentionally convoluted, but it's like you just switch the thing around and it's just a billion times. It's so funny. Both of us feel like we made our point, but like, if you don't know what I'm talking about Signals 10 years later. Conversation I had with Dan Abramoff in the comments here, because I quoted him a bunch. Unfortunately, he deleted all his stuff, so I have a bunch of white spots. Someone went in the chat and tried to add these missing tweets back, but yeah, he was talking about like count videos length, let heading empty heading if count bigger than 0, const noun verb videos or video heading plus count plus noun. This isn't even the yeah, okay, that's fine, but yeah, so then you wrap it in here. Okay, yeah. So we go through this whole thing where he's like, okay, but then you can wrap it in functions. And I was like, okay. When I responded to his thing, I was like, first of all, we could just we could simplify the logic flatter. And then where did I say? We could also just take all your React logic and just stick it in a memo. I'm not saying you should do that, but you could. Anything you do in a React component body, you can do in a frame memo. But my final version, where is it? Where's my final version? I thought maybe I wrote it in an edit. My final version that I wrote back to Dan, I was like, yeah, like, why wouldn't you just write it like this in React in the first place? Instead of having like this, like logic, why don't you just write it like this? This isn't solid. It's solid, you just wrap these in functions, but like this is a billion times easier to read because you're just saying like you're basically saying this is a state and this is how it's derived. There's none of this like mutating variable garbage. You literally just write it as a set of 3 rules. And it's not always easy to write code. Yes, there's duplication. Look, count is bigger than 0 is duplicated here, but it's better, arguably. You could argue that, oh, what if this condition changes? Well, then extract out that condition and repeat it. Maybe this should just be like condition function or something. We could extract count 0 out here and go const condition equals count bigger than 0 and add an extra line. But my point is, like, writing it this way as like declarations, i.e. declarative, is always better than whatever the hell is going on here. Versus functional, right? But that's part of why, I mean, React's whole component rerun model is very much more imperative, right? People are like, oh, declarative framework. What makes React so genius is that they hide an imperative architecture with like declarative syntax. That's why it's genius. It's not because it's declarative. There is already other declarative things. Everyone's like, oh, React makes it declarative. It's like, no, Knockout, Angular back then was declarative. It's that React does a really good job of hiding its imperativeness. There are devs that prefer for loops versus math. I mean, I prefer for loops versus math because it's more performant. But for loops also suggest mutation. Yeah, I mean, it depends on what it is. But you're right. This is there. Yeah, I do hit this when there's a performance consideration. Yeah, definitely. It's just, but you're right. Logically, when you're writing your logic, yeah. Immediate work very well with imperative. It does. Because you know you can throw it away. You can just write whatever you want, which is kind of coming back to what our point was, right? But going here, don't want to get page crash inserts to lead to cascading failures. In most cases, return corrupted and crashed data is not that bad. In reality, all software is a little buggy anyways. So if there's not really a difference, if amounts of bugginess goes up a little bit, probably an unstated bias or having product emergencies, even if that pushes work onto software engineers. I find this a little uncomfortable, but the SFE position feels closer to the truth, even though my values align more with the SWE position, right? So he's saying that like the ops people are probably more right, because being pragmatic, I mean, he's a CEO of a company, he has to be pragmatic. Even though like personally, he's clearly has an engineering background, he feels like his values align more with engineers. So yeah, I love this. Yeah, I mean, people are trying to argue the details, and it doesn't actually matter. You get, though it's technically possible to separate graceful degradation from incorrect result. In a software engineer brain, it's not, because that graceful degradation could would have to be implemented with code, and every line of code is a risk. Yes. Yeah. Yes. I think this is a very interesting challenge, right? I feel like, and this idealism versus reality, I feel like the higher up you are in the chain, the more likely you're going to be on this idealist side. It's more likely that a framework author will want things to crash early. But so you could argue that one of the biggest benefits of the React team working so closely with Meta was that they kind of have to get pulled out of that bubble a little bit. There is a reality to it. It's hard though, because you know, like when you're on the product side and you have customers, you have to learn to say no, right? You have to, like, it's a push and pull, right? So like, it's interesting, right? Do we create tools in a more general sense, or do you cater to software engineers? I never thought about my work that way, but I definitely cater to software engineers. Okay. Ryan Florence performance arc. Yeah, we talked all about the imp mode. Okay. It's time to stop using RSCs and put your fetch pull in use effect. God, David cracks me up sometimes, where you can DDoS your servers because of a missing dependency fault logic instead of worrying about RSC exploits. Oh man, this is the whole damned if you do, damned if you don't thing. Someone probably was like, use TanStack query. But most of those problems are self-imposed. This was just responding, obviously, to their security exploits. I do have something to say about this, even though this is the only thing that I actually highlighted on this topic. I think that okay. Actually, I want to quickly check one thing. I want to make sure that I don't actually have any new posts on here that I haven't covered, and I don't think I do. I think everything that I've covered since here is we've talked about on stream. Yeah. Okay. Except for that, I'll leave that for last. Okay. Cool. It was bound to happen. I mean, there's been other ones that have happened in the past. I think if people looked more closely at most of their front end frameworks, they probably would be able to find security stuff. We always try and patch it right away and stuff, but like, I think it requires a certain amount of usage and a certain amount of, like, before people actually spend the time. The stuff getting found in React, probably in maybe not the same thing, but probably similar things could affect other projects. And I think we all kind of learn from this. I think React being the popular project is going to be one that where you get all the kind of pushback and stuff, because like they should have known, and millions of people use it and all this kind of stuff, obviously. But like on the other hand, I think this is more of an opportunity than anything. I think it's really interesting. I think the fact that we can use like AI to like look at these things and try and like I think there's just a lot of applications of being able to improve security now when we have better tools to kind of look at how these exploits happened. It was a pretty bad exploit to be fair. The fact that they could do remote code execution, right? It's basically the payload that they communicate back to the server was able to remotely like run code on that server, which is, yeah, honestly about as bad as things can get. So you're like, how did that ever slip by? For sure. But like after they patched that, they found two other subsequent issues. These are, you know, this is all part of higher usage and maturing, and everyone kind of benefits from this. Obviously, the people who were hit this exploit are not as happy about this as I am that we're actually learning from this. Security instances, not that like not that I'm aware of. The thing is, the biggest difference, like our payload to the server is a little bit different. We're not sending as much kind of stuff. We don't have the full serialization thing like the way React does. But I don't know. There's probably some kind of. I mean, I'm guessing that's what people will start testing next. Um, we actually after this exploit happened, we actually assigned some people on the team to go preemptively look at our security. We determined that the same kind of exploit wasn't possible, but it's still an ongoing thing. But to my knowledge, it's because this had more to do with the way server code, like the way we do the server function stuff, where we kind of have this like live executing code like through the serializer. That only in solid start's case is the way that it works from going from server to client, not from client to server. So the same kind of exploit couldn't happen. Now, if your server was trying to maliciously run code on someone's browser, it would be possible. But I mean, you kind of get what I'm getting at. Like that would have to be an exploit some other way where someone changed the response from the server that should be a trusted source. So it's like it's not the same sort of thing. The exploit would have to come in from somewhere else. So like there's a slight difference in the way that we're using it, because we're not using, as I said, we're not using Laravel's. We're not like the way we serialize from the server is not the way we serialize to the client or to the server, from the server to the server. So yes, we're currently doing an audit on stuff. As I said, this particular issue, not an issue, but obviously the way that it spun off multiple other issues, we're definitely looking into it. This happened many times in many languages when you shift from sending data info over the wire to sending object behavior instructions. JS is particularly vulnerable due to oddities. Yeah, like prototype inject. Yeah. Your server already gets to run arbitrary code in the browser by sending JS, so that direction isn't quite as bad. But yeah, I mean, as I said, we're in the process of doing auditing because of what happened here. So if we turn anything up, we will definitely get that fixed and let everyone know. What is this, Greg? The idea that arbitrary object constructor allows you to evaluate a string as JS is bonkers. Yeah, I mean, I know this is a weird take, but I do think that the ecosystem in general needs to get stronger on this side. I know ourselves. If you guys remember, about a year ago, there we actually had three critical, not like 10 out of 10, but three critical vulnerabilities that we fixed in Solid, which had to do through injection through SSRs and USL. I I mean, this is just something that things tend to get more surfaced when projects get used more. So I think there's a road ahead for everyone. As I said, I think one of the biggest benefits, I think AI is going to help a lot in terms of analyzing these kind of things. I think we're okay right now. Alexis is involved in, and we have a small team, a few others. I, I'll get back to you, Fuzzy. I'll let you know. I, I, I'll let you know when I know more. Anyway, React's had a hard year between crashes and security stuff. You know, I just being all is fair. I I don't know if we can blame React for all this. I mean, part of it is I do think at React scale you'd hope you wouldn't hit this kind of thing, but the support was found by research, right? It's weird because the only after the support was published, people got hit with it. Yes, pretty much. This is I think one of the more interesting things is I think I think you have to disclose because it's important that people update and they know they need to update. But often more damage happens after the disclosure than the original vulnerability. So like it's almost better to like fix it and then like have it, if you don't think like it's leaking, you know, have it actually propagate out before people actually, yeah, this is a really hard catch 22. And I think something we're gonna have to like people figure out in the future. It's not just hard because it looks bad. It actually causes more problems often. It's like it's ideally you could just get the message to the good players and not the bad players, you know, here. But the reality is, if it's more likely that there's lurkers waiting to exploit, you know, and move on it right away, then people are going to update their projects. It's very hard to patch release an open source without noticing that you fixed and what you fixed and exploiting it. Yeah, I mean that's true too. Give them candy. The other that's the problem. You don't. So I think yeah yeah it's kind of it's a catch 22 because as you said, if you open source, you fix something, you send it out, someone is going to notice, and and you're right, it's even more likely that those bad players, you know, will notice before the people who you know are good ground because they're looking to exploit it. So yeah. Sorry, there's just some noise. I've got Discord in the background. It's like I ended up ringing in my ears. I thought streamer mode automatically turned that off. Anyway, uh, what? While the best part of the year, and the number of reports is very low since the factor is low. Those who knew about those who are using it. Anyway, I think this is one of those things where yeah, I don't know. It has a ripple out effect, and I think in the end we'll all be better for it. We talked about this. Yeah, okay. So Ryan Florence's performance arc. It's funny that the order of this is out of order. A weird thing happened when Redux took off. Everybody started freaking out about re-renders, and we haven't stopped since. Now we've got signals, fine-grained reactivity, React File, React Scan. I think the VDOM is enough. Clean up network waterfalls, render less, better design. Cool. Keep it simple. Reactivity was a mistake in my opinion. There are some obvious reactive services, but in most cases you're already triggering changes somewhere. Calling a method to re-render when you know you need to just makes life easier for everyone. This is, oh man. I don't even know if I want to talk about it. Like there's a bunch of fanboys that really like the this out update and remix. And it's like a red herring. Like it actually doesn't make anything simpler, just exposes more surface area for you to screw things up. Sorry, just a second. Just sorry, 2 seconds. All right. Yeah, sorry. The funny thing about this, it's just it's an interesting take. He said that I think in another post, Ryan blames himself for part of this with context. He basically said that context was the problem. Do I have that tweet somewhere? I have to look. Sorry, I didn't bookmark the one I wanted to. Oh yeah, this one. I should have bookmarked this one. I have a hunch. Please pardon my threading. React VDOM became a bottleneck for one reason, global context, and guilty parties are Redux and me. When Redux got popular, suddenly React router state updates weren't making it through the tree down to link. They stopped knowing they were active or not. Why? Because Redux Connect blocked context updates. Redux knew if all state lived in a global store, every action would cause too much scripting by reconciling the entire VDOM tree. So Connect did two things. Connected the component to the store and memorized the component so it wouldn't update if props didn't change. The problem was that React router state didn't live in the Redux store, it lived in a parent component. When React router said this set state location, the reconcile bailed on every Redux connected tree and didn't get the update. Thinking this through, we created a funny library called React Broadcast with similar looking API, consumer subscribe to providers, blah, blah, blah. I remember it's fascinating. Easy to see the value, hard to see the cost. Can't link because the account got deleted. Soon after, React adopted the React Broadcast API directly into React itself. Sebastian was right, all hell broke loose. Problem isn't that there's a dozen global providers. The problem is that to update a provider's value for consumers to read requires reconciliation of the provider value. Sometimes consumers don't even render the value either. And that brings me to React3's context API. Context values you just variable assign in the component's internal function scope. They don't require update to be set. With this, so you're saying context set then update. This tweak, you can update a root context without triggering a reconciliation. You localize component update by putting an event targeted, blah, 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 inside get provider, add event listener, okay, blah, blah, blah. Event targets are part of the platform, the updates are localized, blah, blah, blah. And he's right to a degree, but I think I come to a different conclusion from reading all of this. I love the trail of context providers, but like we can blame bad context use, but as long as state update equals component update, we hit this, right? So he's saying state update doesn't equal component update because he's just setting a value and then he's calling update himself. But that's because his components don't re-render, essentially. Only the views do. And he's saying like, the thing is when he does call this update, it's still going to be wherever the this is. So like there is still this kind of like he's not firing it like a billion times or override. More importantly, he's not overriding like someone else's work. This is the problem with memoization of trees. All it takes is one change for the whole memoization tree to get thrown away. Is there any use case where the runtime reactivity adds up and the manual approach pays off? Generally speaking, definitely. Manual is always going to be faster if done efficiently. And so it's always possible that you know the overhead of even tracking the reactivity is an overhead. The challenge here though is you have to know exactly what to change here. And when you're starting talking about data that gets distributed through a tree, he's not talking about doing things smartly. He's talking about just like deferring, re-rendering everything. Do you know what I mean? Like the problem with the memoization approach is that, as I said, one piece higher needs to rerun, or one thing invalidates, or one thing like above decides to recreate the whole thing below, and you lose it. And so what did I say here? We can blame bad context use, but as long as stated we hit this, the inability for these to be innately decoupled is the issue. Now, obviously, we could be smart about not trampling each other, maybe schedule better, but this needs to go from somewhere above to somewhere below. And if the only path through is rerunning components, you'll be picking up extra work. Memoization can cut off the untaken path, but it can't do anything about the path you have to travel. Yeah, that's what I was trying to say here, is that like, even this is kind of like a common thread that I'm seeing with a lot of the remix kind of stuff is they understand the problem, right? They see it. They can see the symptoms of the problem. So they go, okay, this is running too many times. This invalidates this. So they're like, if we take the control ourselves and not do the dumb thing, then we'll be better off. But the thinking is still the same thinking that led React to where it is today. So it's like you're not actually you're pushing back you're pushing back like hitting the symptoms, but you're not fixing the problem. It's like getting rid of use effect, but then still writing to state everywhere instead of deriving. You get rid of the performance problem because you're not triggering a bunch of separate updates. But, and to be fair, in React it's batched usually, but you're not actually solving the problem why the logic is so disoriented and why you can't actually make sense of what's happening and why it feels like it's coming from all over the place. Like the same reason that you don't know why your component's re-rendering 10 times. Sure, now you're not re-rendering 10 times, but you still don't understand your component any better. What happens is how you can do web framework without considering global state in the first place. Fair. Yes. I mean, this is why you choose reactivity systems, not because they're more performant, because it makes it easier to manage consistency. There is a point here where the performance for the mid to high end hardware is better now than say in 2015, and we can always yearn for simplicity. Yeah. So this is the counter argument, right? Like you can just be like, look, the baseline has changed, the assumption has changed. Good enough is better than it ever was, and it's true. Remember that circles demo I showed earlier, where every framework, even Backbone, is the same. Backbone was not, I mean, it was faster than Ember or whatever, but it was not fast. But that Circles demo now, they're all the same. Whether you're using Backbone or you're using Vanilla.js, it's like each loop is the tiniest bit. Now, obviously, I'm not drawing enough circles, so if I draw more circles, but I think it's important to re-ask these questions often because of this reason. Because even if nothing's changed, things change. So we have to, most often, innovation comes from recognizing a simplification somewhere and then going, okay, well, now that we can change our assumptions, we can go slightly different direction, and that unlocks a whole bunch of stuff. I am all for that. As I said in the past, I think a different stream, I said, there's the classic, one step backwards, two steps forwards, like so you step back and then pivot, and then you do this. The Remix guys are the best step backwards, like one of the best step backwards group in this industry. I always look to them when they like realize that an assumption can be changed. I think that kind of thinking is really necessary. I don't know if they're always the best step forward people, but that's fine. I'm biased. I feel like I'm a very good step forward person, but I would be biased. Alice Russell is always there to point the lower end has not kept up at all. Yeah. So yeah, that's fair. But it is there's something here. I just, this is kind of the common thread that I'm seeing a lot. It's like a lot of the same stuff that inspires Remix is what inspired my work in Solid and continues to. So it's just like, yeah, it's interesting. I do think though that like this isn't their fault. I think this is inherent. Like whether like what ends up happening in a system like this conceptually is you eventually end up calling this dot update yourself too much because you start overcompensating for like, oh, why did this thing not update that time? Oh, let's put a this dot update here. So like the React problem ends up coming back. It just comes back slower, and it's in this case, it's kind of your own fault because you're the one who did it, but you didn't have to add the this dot update. Implicit I talked about later. Non-tearing can easily opt in without much code. Okay. I'll take a look at that later. Yeah, I mean, when I talk about opt-in of this stuff, it's I don't want modes. I'll have to look later to see what you're talking about, but like I don't want modes. I want it's the wrappers, it's the API service I'm trying to avoid. In 2026 is going to change about web components. No. See, the thing that you have to consider is sometimes like performance. Like, for example, if web component performance got significantly better to the point that it was almost nothing over vanilla JS, like over like just plain like doing it, like they were basically invisible from a performance standpoint. They're not today, but let's pretend they were. Would that change my opinion that they're the wrong abstraction? No. So yeah, I don't think that changes anything. Right. Usually it's the capability of the hardware, something fundamental, something that changes the performance. I often, when I talk about performance, usually it's about like budget. It's not about like necessarily being the absolute fastest. It's sometimes performance makes good enough, right? Which makes React generally like a good bet, right? Because they're kings of good enough. And in theory, over time, the universe will be good enough that they're good enough, continues to be good enough, even better than good enough, perhaps. But I'm not necessarily satisfied with that, but his conclusion, Ryan is satisfied with that. He's just like, if we fix a couple things, right? Like this, which is fine, because to him, this is still the simplest model. It's not surprising that this is the conclusion he'd come to, right? He's like, this is the simplest model. If I can just get rid of the slow piece, then I can continue with my model and it'll be good enough. That's the conclusion, and that's fair. Where I'm arguing, you know, sorry, I have to go back to where did my bookmarks go? I was in my bookmarks on this tab, I think. Where I was basically going like this one. See, he's saying, I think the VDOM is enough, right? That's its conclusion. I'm like, it's not your fault. The architecture is slow, right? Good enough versus not good enough. Anyway, but yeah, okay, let's talk a little bit more about this. A new abort controller is kind of expensive. I'm glad he's testing it. People are going to give him a snark about this. Use the platform, that's the upfront cost, then use the framework instead. I mean, I feel like this is a very framework author thing to write, because this is the reality. You don't think every framework author would want to use the platform as much as possible? Obviously, the platform changes, right? So we make assumptions based on what was available at the time. As new stuff comes, we can't always keep up with it, so maybe change it. So Ryan's coming as say the newest framework author, so he's seeing new tools that we didn't have available when we made our assumptions. But the truth is, sometimes these things are not fast, and the abstraction's not quite right, and we just, instead of waiting 10 years for it to change in the standard, we just do our own thing. We're still using the platform under the hood. We're just not using that particular feature. And I think this is a very important thing. You know, years later, someone will be like, oh, why didn't you complain to us loud enough? We could have fixed it. It was just a performance regression. It's like, how the hell are you supposed to know that abort controller is supposed to be slow or fast? Like, what's kind of expensive? Right? I'm talking specifically about an issue that came up around clone nodes versus import node or whatever, you know, like, because you have to use a different one with web components versus normal DOM nodes, and one was way more expensive. Apparently that was a bug. We didn't know that. We just spent almost a decade working around it. So like, I don't know. That's a few. That's a decent amount. Do you know why? I don't. Also, you should get better time, right? The platform constantly gets faster. I love how these things are all on point. Anyway, it's just interesting. I'm glad that he's testing these things. That's the important thing. He's actually made his own kind of fork of something very similar to, like, these are the categories from the JS framework benchmark, if you noticed. And he's kind of testing all the frameworks in here. So I've been really enjoying following along. One thing that I thought was interesting about this is he's basically showing where Preact signals has certain overhead versus not. Like this is just the JS framework benchmark again. I guess it's like a little bit different, but it has the performance characteristics are the same. As I mentioned, every benchmark is kind of the same, and I think even if you modify it, you end up seeing consistent results usually because there's only a certain type of benchmarks. Good enough-ish, enough. Well, the problem is there's two different things. The good enough argument is like the Theo argument. He makes this all the time. He's like, things are only getting better, so React will be the king forever. Because if it's good enough today, it'll be more than good enough tomorrow. I am more optimistic than that. I think people's expectations of what they get will continue to grow. And whenever the baseline, we get closer to the baseline, we realize that we can achieve more, and we get more ambitious. So I think this is moving goalposts. I don't think good enough stays good enough. Even if the base moves up to meet, there's always something better. And the thing that, if it doesn't change, the tool used in the middle does actually end up sliding down over time if it doesn't update. I that's my belief. Even if the hardware comes to meet it, that hardware coming to meet it also raises the ceiling on expectation. This constantly happens over and over again. Good enough rarely remains good enough, even if it's better than it was before. You know, like even if the good enough has improved. It's funny. There's more Ryan Florence. He just kept on going. I did bookmark that one. There is one more that he did. I think somewhere in his chain of crazy benchmarking, he called us out because he added SolidJS to it, and it like won at every single one of the benchmarks he did. It's not surprising though, so there's probably not much to say about that. Yeah, I think that's fine. Okay. I think I'm pretty much done here. I've got one more story here, and it's related to what I was doing the time slicing. I want to thank Replay.io. I don't know if you guys remember this company. It's ironically the one that Mark Erickson, Redux guy, also works for, who was on the stream earlier talking about stuff through the chat. But they have an AI gen product, but their original product was this time travel debugger. Honestly, this is the best thing ever. I almost feel like I want to like look at it a bit on stream at some point to show how I fix issues. But you literally can record the browser and replay every browser event. That was the only way I fixed that time slicing demo. There's a weird thing where it was sticking on a couple numbers because of like some timing thing, and I was missing setting modified on effects under some. I would have never found it because it was so hard to reproduce, and if you tried to put a breakpoint, it would break before you could reproduce it. Instead, I'd record it, walk forward and backwards until I could find exactly what was missing, and then eureka moment. Honestly, this is the best thing ever for hard debugging. They don't talk about it much in here. I think replay. Basically, what ends up happening is you can install it in the terminal, and then you can just tell it to open a browser window and record it. And then when it's done, you close the window, close everything. It's like a separate isolated Chrome browser window. You can then open the replay. Actually, you know what? Let's see if I can. I'll show you guys a replay right now. I can actually show you the replay that fixed the bug really quick. Sierpinski bug. Okay. I just want to show this because it's so freaking cool. Okay. Actually, quick question, maybe a little off topic. Is it you work on Solid 2 or is it a team effort? Different people that work in different parts. The actual putting it together is mostly me. A lot of people help me test, which is important. Even some people not on the core team, actually, people in chat here are actually testing my demos and poking holes in it. But like the core reactivity R3, Milo been building. But yeah, when it's coming to most of like the trying to put it all together, like Dev was making demos and examples and testing features. A few other people in the chat, like I don't know the actual name, but username Gavin. People have been helping a lot and actively in the discussion. But yes, for the most part, doing the release and stuff has been mostly me on my own. We have other people working on other parts of the ecosystem, like docs. There's already been a beginning of a little bit of a docs effort. As a testing against AI and testing like that. There's people using it to do stuff, but the core development, is been mostly myself and Milo so far. Because most of it's been the signals work, to be fair. Tito also, sorry, I should mention Tito. He's been doing all the updates to DOM expressions, aligning stuff with the new standards, types. Yeah, so actually he's done a huge amount of stuff on the JSX compiler as well. But each person's kind of like in their lane. When it's the actual like core signals library, Milo and myself, core solid packaged myself, and then Tito all the JSX compiler stuff primarily. So I'd say, yeah, mainly three of us. We've had other people like working at different points, like on the implementation, but yeah, I'd say mainly the three of us. Web fragments, because it'll make it easy to migrate. Yeah. Yeah, for like enterprise, I think that's the way. But we also have to be able to provide a good enough solution that's worth migrating to. Okay, cool. Do you want to see this out? Check this out. DevTools, bam. Now, this is crazy because this replay is nuts because like it's gonna take forever to load because there's like thousands of nodes here, like in lines that are running at quick succession over 10,000 times. So what was really kind of cool about this is you can go in. Oh, it's funny, it remembers my breakpoints. But see, too many times, over 2,400 times. So what I ended up doing is setting a window. Here, you can actually move the window to a certain point in time, but even this window is too big. Okay. Before this, I'm going to show you the bug. We're going to look at the viewer here, and we're just going to play, and I'll show you the bug. So I move the mouse over, I highlight the 1, and then when I move away, the 1 stays there while the 2 is there. See? See how it's 1 and all the other ones are 2? This was the bug. It's like, how the hell do you isolate that bug? Like, why this one stayed 1, right? So I'm trying to remember. I'm not going to go through the whole thing of how I found the exact moment, but I basically focused in to that moment in time. Essentially, let's crunch this. We don't need any of this. Where it went from 1 to 2, somewhere around here. It's funny because this is so. We're really making it work here. See if I can move this back to here. Because you can scrub it backwards. Let's see if I can scrub it even further. Because there's just so many events happening over this time. But I was able to get to a point in the schedule here. Yeah, see now runs only 24 times. Why is it not showing up? Yeah, here we go. You can actually move forward to each time the function runs this chunk of code, like hits this thing. You can, or you can go back to it, rewind to it, and then when you're in here, you can literally like go, okay, let's step out. Oh, let's step back in again. Step over this. Oh. Okay, I'm reading this. Oh, wait. Let's go back. You can actually walk forward and backwards through the code, and at any point, like, look at what... Okay, C is null in this case. What's L? So, like, I was able to find essentially that we weren't... I was in a loop. Let me see if I can find it, but it's in Flush. What I ended up finding is that I was inside this pending loop, which is when we add set the final values. And this loop still gets called an absurd number of times in this thing, which is why I probably can't put a breakpoint here. I need to focus even thinner, unfortunately. Oh wait, did I lose my window? No, I didn't. But I managed to narrow it down to looking in here, and I saw that one of the nodes was not marked as modified because it had run in a previous cycle outside of the transition. And then I was able to realize that in this loop, I needed to set it to modified if every time the pending value was set. It's kind of a silly bug fix, but what I want to highlight is just how freaking hard this would be to solve otherwise. Yeah. Well, and that's the thing. It just opens a browser. They basically hijacked a version of a browser to record every single possible event. So like it really replays, like this one doesn't have any clicks, but like what are there's no events in this one. But if I go out of this example and go to tab auto disposal, this is a more traditional kind of scenario. And I go into DevTools, what we'll see right away is that there is 3 click events. I clicked here to dose, click back to Uno, and then I click back to dose again, right? And then unfortunately for me, when I get to the next thing, the page is gone. I still need to fix this bug. I'm looking into it. It has to do with automatic disposal during transition. But what's cool is like, you can just jump to this point in time of when you did the click and then be like, okay, you know, let's go Source Explorer, look at my code, and just, you know, this one's a little bit more manageable. I think there's I don't know if I have any breakpoints in this one, but it's, I'm not doing the best demo of this, obviously. It's just, it's so crazy that you can look at some kind of, yeah, handle node. This is the event handler. Yeah, it disappeared, but see, these are what happens when you click in Solid and the event delegation goes into the handler 3 times. So then, you know, I can go to that. Then, like, what happens? The first time I click and I call handle node, and then when I step into this, I clicked one, set tab 1, set signal, value change equals function, a equals b. Yeah, okay, good. So it's equal. Then has the value changed? Yes, value changed. Is the element optimistic? No. So it's not pending, add it to the pending queue, set pending signal, status flat. And then, you know, like, let's, you know, status flag, that's fine. Let's step back out. And then notify subs, schedule the update. Anyway, you get the idea. Oh, it's like, oh wait, let's go backwards before we notified the subs. Oh, let's go forward to after we notified the subs. Oh, like, yeah, I mean, it's, let's go, where is it? Flush again. Flush. Let's go to when the transition ends. If there's a transition and it's not complete, do this. If it is complete here, it looks like the transition ends. I'm going to remove this one for a second. Transition ends after our click right here. Okay, so we jump to where the transition ends, and then we're going to walk through. Okay, let's do the storing. Okay, good. And then let's update our pending values and commit them. Good. Dispose anything that's not used anymore. Okay. How many pending nodes are in this one? Not that many, right? 56. Okay. Don't feel like walking through that. Let's just jump to there. Where am I? Let's jump to 257. Yeah, there we go. I'm just going to get rid of that breakpoint for a second. And then let's let's walk over there. Let's run the render effects. All right. Oh, it's funny, the UI didn't update, but if I actually look at the DOM here, we're going to actually see the page dose here. See, let's go back before we rendered. Uno, apply render effects, dose. So that's where it did the actual rendering update of the DOM elements. Of course, we can walk into it if we want to and go through our effect code, but you can see the thing, you're like, oh crap, I missed it. You can go, okay, let's go back. Let's try it again. Anyway, you get the idea. Like, this tool is just amazing. I can't speak enough about how amazing it is. Anyways, I think I'm done for today. Done for the holidays. So yeah, I think if nothing else is going on, I think I'm gonna call it quits here. There's a couple more questions in the chat. Let me see if I can see that. It's funny, I see the questions in Twitch, but not in here. Could I use XP hands with testing anything Solid 2.0? Come to the next channel. We were at a really good place where like a bunch of people were testing stuff, but then when I went to implicit transitions, I kind of had to restart everything. So like there was a lot of people moving stuff forward for a while, and then I kind of pulled the reset about a month ago when I realized I could do this new reactivity model. So then it was back to basically just me and Milo working on stuff, but we are getting to a pretty good place. I'm only missing a couple more features on the client side, and then we start like testing and trying this stuff out more. I mean, you can, all the stuff's in StackBlitz, you can download, it's all in npm and GitHub under the next branch, so you can definitely install and try it in projects. The Vite plugin Solid, I think it's getting updated for next. I saw someone else post something there for Solid 2.0, but I haven't tried it yet. I've been just using a roll-up build essentially. But yeah, I like the stuff that I'm showing on stream is very hot off the presses. Very close. Early in the new year, we'll be in a good place to have more people testing this stuff out, and we'll probably do an alpha release at that point. Do you play those guitars on the wall? Yes. Yeah. All right. Yeah, I think it's so funny. I don't see these messages, but I guess they happened a while ago. Do solid contributors use coding agents on the project? And I don't. I have to admit, I haven't really used much. I mean, I use like Copilot, but that's about it. So we do have like people working specifically on like testing how well AI works, but I don't tend to use AI on the work I do. Anyways, we need to stream, just play guitars. I don't know if that'd be that much fun. Yeah, I think it costs 25K subs. Oh wow. Haven't paid too much. We won't know until it's actually like the APIs aren't even finalized. This right now, I call it experimental. The next phase will be alpha, then beta, then RC, and then release. So right now, because like I just did a big reset, like the answer would have been different a month ago. So until we get to alpha, when I feel that like I'm done testing ideas, and I'm very, very close to it again, then I can't really say for sure. On the positive, the core APIs, like Surface, hasn't really changed too much. Like there's some differences in stores and like new primitives, like async, create async versus create signal, or sorry, create resource. But I think there are some behavioral differences that are worth talking about that are, trickier. Like that I'm looking at. I've talked about them a bit on stream, but those details are also, like automatic batching and stuff. Like those are details that still like need to be, put up to RFC and stuff. All right. Anyways, you all have a great holidays, and hope see you guys all soon in the new year. All right. Have a good one.